Yeah, good evening to all. Yeah, good evening. Good evening to all. Perfect. Yeah. Hi, good evening. Yeah, thank you for everyone. Very good evening. Yeah, good evening. I'm good, very good. So just class के बाद अब तक सो रहा था मैं, right? I was not in a mood to wake up. But anyhow, it was very nice sleep. Yeah, good evening, Nishu. Pesh, good evening. Kajal, Kshat, hi Apurv. Put in back, good evening. Yeah, TM planning on Monday because other classes are going on, right? So if I take the classes, then other classes will get disturbed. By the Sunday, I think all the revision classes, Maha revision will be over. Then I'll be taking on Monday, part 2. Oh my god, put in 4 hours. Okay, try to sleep after this class at least. Yeah, good evening, Satya. Right, good evening. Yeah, thank you, Shifu. Aniket, good evening. Yeah, happy Republic Day. Who are missed in the morning. Yeah, Nishu, happy Republic Day. Good evening, Patel. Yeah, Rupesh, good evening. I think yesterday Rupesh was telling, I know I can take the live class for more than 12 hours, 14 hours too, but you cannot watch the video after 12 hours. The YT will keep only 12 hours, remaining will be trimmed. Then the students who are watching recorded, they will get an issue. Live class will go, not an issue. That's why I stopped immediately. But to take the second session. Yeah, good evening, Patel. Yeah, Azan, good evening. Yeah, Aish, good evening. Are we ready, Rick? Yeah, Shrank. Thank you for reminding. Slept well, no issue with the compiler. Are we ready? कल का पीडीएफ शेयर किया था बट मैं सो रहा था ना तो टाइम हुआ शेयर करने में Are we ready? Yeah, we'll upload it. We have the recorded video, Sugandha. We'll try to upload that after 12 hours. Compiler is not the bigger subject, right? We can finish. No, I don't know, but we can finish very quickly. Ready? Good evening. Yeah. So how did you get the Prabhakar PDF? So let's ask the Prabhakar, how did you get a PDF, and ask him. You can discuss in the chat with him, right? ओके आज करेंगे ना कंपाइलर का रिवीजन अल्फा. Don't know, Ninja. That depends on how we go well. Okay. So visit the PW app. There you can download the PDF. Right. Those people who did not receive the PDF, right? Just go to the app. You can find it. Upload हो गया ना? Okay, that's great. So welcome to all compilers. Are you compiler or not? Because you need to process what you learned, right? Like a compiler takes a program and processes and produces another program. Similarly, we are all compilers here. सभी कंपाइलर्स को धन्यवाद और शुरू करते क्लास. Is that voice clear? Should I increase the volume? I think volume is fine. Okay. Just let me know. Is there any problem with the voice, audio and video before starting? अभी clear है? Because I said that a little bit margin here. Volume is low. Please increase it. I don't know here. Let me check once. Now it's fine. Just let me know. Voice is not audible. Give me a second. I'll just contact and I'll get to know. Give me a second, guys, before starting. Yeah. Yeah, hello guys. I think the volume is high from my side. Let me begin the session. So those people who are watching through the headphones, right? That might be the issue, but everything is fine from my side. Okay? चलो शुरू करते हैं कंपाइलर का. So कंपाइलर का वेटेज. Compiler का weightage is around 4 to 6 marks. Average expected 5 marks from this. The syllabus that you may have an issue with the code optimization, but apart from that, the most of the content will be very clear. That questions from lexical analysis, less expected, so we'll finish as soon as possible. The most important topic is syntax analysis. It will take much time to cover. Then we have SDTs. Then we have code optimization. Before that, we'll study intermediate code. The next important topic is intermediate code. The code optimization is recently introduced and the questions are also coming. Okay. And apart from this, if anything else you want to learn, like runtime environment, maybe you can learn static scope, dynamic scope, and call by value, call by reference. So those techniques you may learn apart from this. Yeah. Good evening. Yeah, Ankit sir. Good evening. Okay, Ankit. फर्स्ट कॉन्सेप्ट यहाँ पर लैंग्वेज ट्रांसलेशन. सो कंपाइलर में मेन जो चीज़ है लैंग्वेज ट्रांसलेशन. सो हर चीज़ यहाँ पर ट्रांसलेशन के ऊपर डिपेंड होता. सो राइट, कंपाइलर में कितने फेसेस होगा? हाउ मेनी फेसेस आर देयर इन कंपाइलर? Tanish, please attend the part 2, right? So those people who are missed in the morning, right? We will be having the TOC part 2. There I'll be covering only Turing machine and disability. यार फिर कल की डिस्कशन चल रहा है आज की. गुड इवनिंग क्रिश. 7 फेजेस होता, राइट? सो 7 फेजेस का काम क्या है? ट्रांसलेशन, राइट? कुछ तो ट्रांसलेट करना है समझने के लिए, और जो हाई लेवल लैंग्वेज है उसको मशीन लेवल लैंग्वेज में ट्रांसलेट करने के लिए कुछ तो ट्रांसलेशन करना चाहिए. सो ट्रांसलेशन का काम क्या होता? बेसिकली नॉट ओनली 7 फेजेस, कितने फेजेस है? 7 फेजेस. और ट्रांसलेशन में कंपाइलर के अलावा, आपको पता है यार कंपाइलर में 7 फेजेस तो है, राइट? 7 फेजेस तो है. लेट्स से 1 2 3 4 5 7, ये तो कंपाइलर है. बट कंपाइलर अलावा और बहुत सारे कंपोनेंट्स भी हैं. एक और कंपोनेंट है इससे पहले, वो कंपाइलर से पहले प्री प्रोसेसर है, बट इट्स अ पार्ट ऑफ द कंपाइलर मोस्ट ऑफ द टाइम्स. एंड एक और यहाँ पर एडिटर होता हूँ, और यहाँ पर एक असेंबलर होगा, और यहाँ पर एक लिंकर एंड लोडर होगा. तो इसके बाद ही आपको फाइनल आउटपुट मिलेगा, राइट? सो हियर व्हाट वी राइट, वी एडिट, यू कैन से एडिटर. तो यहाँ पर सी कोड हम टाइप करेंगे और सेव करेंगे. उसके बाद हम प्रोवाइड करेंगे कंपाइलर को. तो ये कंपाइलेशन प्रोसेस स्टार्ट हुआ. बट जो पहले कंपोनेंट है प्री प्रोसेसर, इसका काम क्या है? जो सी कोड है, लेट्स से सी कोड इज एन एग्जांपल, इसको ट्रांसलेट करेगा और प्री प्रोसेस्ड सी कोड प्रोड्यूस होगा. मतलब जो भी सी कोड में एश स्टेटमेंट्स होता है ना, जो भी एश से बिगिन होता है स्टेटमेंट्स, उसको ट्रांसलेट करके प्रोड्यूस करेंगे हम. यहाँ पर एश नहीं रहता कंपाइलर में. सो कंपाइलर ए प्री प्रोसेस्ड सी कोड को लेकर असेंबली कोड को प्रोड्यूस करेगा. क्या कोड है वो? असेंबली कोड. ये असेंबलर का काम क्या है? ये असेंबली कोड है, इसी को मशीन कोड में कन्वर्ट करना है. बट इसमें सारे जो एड्रेसेस है वो विदाउट हैविंग नॉलेज असाइन करता है. यहाँ पर क्यों रन टाइम में क्या एड्रेसेस अवेलेबल है, क्या नॉट अवेलेबल है, assembler do not know about it, right? Assembler do not know about it. So it will just produce the machine code by assigning random addresses, right? So इसका नॉलेज जो है वो अकॉर्डिंगली असाइन करेगा. बट उसके बाद दो काम होता, एक लिंकर का काम और लोडर का काम. लोडर तो हमेशा रहता, बट स्पेशली इसको ठीक करने के लिए लोडर तो जरूरत है. देन आपको रेडी होता एग्जीक्यूटेबल कोड. ये बाद में भी यूज होता, लिंकर एंड लोडर, राइट. ये एडिटर से पहले कुछ नहीं होता, राइट. ये एडिटर यहां से स्टार्ट होता. एवरीबडी क्लियर? यस सत्या, इज एवरीवन क्लियर? You take the C code and compile it. So in the compilation, of course, this is a compiler. What is this? Compiler. So we have the syllabus here, and just before what is there, after what is there, we're just looking at it. But we are only learning compiler here. Anything you want to learn, that you can learn outside. Like some things you learn in C language, something you can learn in operating system, right? Some of them you may learn in even computer organization. So there is a lot of connection between all the subjects. Everybody? गुड इवनिंग चंद्र प्रकाश. एक वन एग्जाम्पल लेके ट्राई करेंगे. वी विल टेक वन एग्जाम्पल टू अंडरस्टैंड. सो लेट्स राइट स्मॉल सी कोड. ओके ना, which one is a better? Let's say I have hash include p1.c. in this I just call void main. Let me call f. So this is one program. There is another program. This is actually p2.c. It's a main program. And p1.c helping. I'm taking the help. So here I'll just write hash include what stdio.h. So I'm just using void f. Here let's say printf 1. That's it. So what you have to do, you have to compile these two programs separately. So p1.c will be compiled separately and p2.c compiled separately. So two programs will be compiled separately. So it has to be preprocessed, it has to be preprocessed, right? But when you are compiling p1, then stdio.h need to be linked, and when you are compiling p2, and p1.c should be linked to p2. So when you are making one program, right, when you are running this p2.c, then p1.c was linked as well as stdio.h is linked. So total how many programs we have here? Total 3 files we have. One is stdio.h, another one is p1.c, other one is p2.c. So if you want to run this program, right, all the 3 should be linked. But this linker is going to help you during runtime and also just before runtime to link them, because you need to make it available just before execution and during execution. So this part is available during after compilation and also during runtime. So now till here you just need one program only, but after this you need to link with more than one program. Linker is going to tell you that how to make one program using more than one file. So because the control needs, the operating system need to understand something like this. The execution will begin from here and it goes inside, and f is here, and it executes printf, and after executing then it comes back here, and the control will go away from here to OS. So this whole control just looks like a sequence. But who is making this sequential execution? That linker is going to link. Then operating system can understand what is the sequence of execution by looking at this, all the linked available external files. Okay. So what is the preprocessor job? To remove the all hash include statements and understand what to do with that. What is the compiler job? And every C statement you need to translate into assembly code. So very simple example I am talking about. Let's say if you have here int x and x is equal 10. Then what is the job of compiler? Oh, int x. So the compiler will remember something. Okay, there is a table inside. Okay, x is integer type, and it has some other things to remember. Okay, x is id type and it is integer type, right? So many things are there to remember about x, and compiler will remember this, and it will send here simply it will send here what? A move a comma 10. That's it. That A is an address. This A is going to have an address, and that address it's going to be allocated with integer size. So somehow it maps that X and A are actually similar. The X requires integer size, and A, it might be an address or register, so that location is going to be specified with integer size. So here that assembler do not know what is integer. It only knows what is the size, how much size you need. Oh, integer, let's say 4 bytes. So here you are going to take an address which is going to occupy 4 bytes. Somehow it is mapped in symbol table. Now this assembler takes and converts into what? Okay, don't know what is it, just I am saying it. It's some machine code, and here that operation move is mentioned, A is mentioned, 10 is mentioned, and this whole instruction is also stored at particular address. So in the main memory, this zeros and ones will represent the corresponding code, corresponding instruction, machine instruction for this assembly instruction. Okay, and this instruction will be understood by the actual operating system or actual system. Okay, so system takes this code and runs because it's a machine code. Machine can understand it. But this I've explained only for one instruction, right? But you have a lot of instructions and you need to do a lot of things, and you have a lot of programs and you need to do a lot of things again. So linker job is to link external objects. If you have something like that, external files or external variables or external functions, that can be understood only by the linker, because compiler cannot understand what is hash include p1.c. It knows that it is some other file, but linker comes and links what are the functions that you are using, f you are using. So if it's actually address, somebody you need to specify where is that f, who knows that f, where is that. So linker knows exactly where is that present, right? Where is f present. Yeah, predefined files are many types, right? Predefined or isn't defined, that doesn't matter. It is external means external. So for that predefined, you will be having DLL files, dynamic link files. You need to library files, right? So DLL files are available, but these are user defined. So compiler need to compile and you need to link from linker. Linker either link user defined file or DLL files, doesn't matter. Correct. Okay, all right. Fine. So anybody is facing issue with the audio and video? Let me cross check one more time. Are we ready to go further? Everything is a program, yeah. There is nothing like here. Assembler is a program, linker is a program, loader is a program, compiler is a program, preprocessor is a program, editor is a program. Everyone is a program here, right? There is no device here. Everything is a program. Right? No doubt, even compiler is a program. Everybody is a program. It takes some program and converts into some other. Okay, but translation is very important. You are trying to do translations everywhere. Everywhere you are doing translations. Okay. Okay, we'll not spend much time on other things because I feel that you are aware of other components. My main target is compiler. Okay, are we ready to start with the compiler? Are you want to discuss anything in the translation apart from the compiler? Let me know. That depends. It's whether you assume same or not, that depends on your compiler. Object code is assembly code, and if you want to see whole translation, object code is the executable code. So on which reference you are talking about object code? Compiler, object code is assembly code, right? But if you are looking for whole translation object code, object means target, there is going to be the executable machine code. So that's depends on what is your object. Right? You are preparing for gate, your object is gate crack. I'm preparing for GRE, then object is GRE cracking. Right? So object is going to change, it depends on your translation, or depends on your approach, depends on your nature. right? Yeah, loader is used to load not only just program, here also does. Those people who are not aware of linker and loader. See, loader is different, but we are talking about this language translation. Here in operating system, loader is having lot of jobs. You need to load your programs, modules, all works done by the loader only. Even bootstrap loader loads operating system. There are so many types of loaders. I'm only talking about a loader which takes care of C program translation. Right? There are so many loaders. During this translation only I'm talking about. This, what is the job of loader in our C programming translation? It is to perform relocation. If any addresses are not available, change those addresses to perform relocation of data and code. Because sometimes address of the data are not available, sometimes address of our C code, you need to change it because that address might be occupied. Then this is the main purpose. Apart from this, memory allocation, deallocation requires the loader support. Okay, apart from this is the main purpose during translation. And linker is to resolve. You can combine both the features in one program also, to resolve external references. This external references, comes from the mainly files, means programs. In the files we will be having functions, and apart from the functions we will be having variables, many things. So files will be dealt during pre-processing. The preprocessor will identify the file name, but during linking the functions and variables, you need to understand you are calling printf, where exactly it is available and what is the address of that printf. So need to be dealt with the linker. And you're using external variables. Let's say there is a global variable x which is not there in our program but is there in other program. Then that's an external variable. So you need to catch that address. Where is that? So that will be handled by the linker. Right? Any other points? Everyone? So main important points for the linker and loader. Because practically there is a big approach for implementing linker and loader. Linker can come during compilation time and execution time. During compilation process, just before execution, you may require static linker. There are two types to implement: static linker, static loaders, dynamic linker, dynamic loader. So mostly we use hybrid type. So some part of the linking you need to do before, some part of the linking you need to do runtime. So we use the hybrid linker and loader. So we need both supports, static and dynamic type. Right? This linker can be implemented static as well as dynamic. But today we use a hybrid model. We can't use only static, we can't use only dynamic. Okay? Similarly, the loader is two types, static and dynamic. So we need to use some loading part just before. See, the main function, if the address is not available just before the execution, how execution can start? No, right? So loading should be done just before, little bit, at least little bit. So remaining portion you can do dynamically, but some part you need to do static. Okay? Are we ready to go to the compiler? This is not about the compiler, it's just after the compilation. Okay, are we ready to learn the phases of a compiler? From here our syllabus begins. Yeah, good evening Dheeraj. How many phases that we know? How many phases that we know? You said 7, right? How many main phases of the compiler? Okay, you said 7, that's good. How many main phases of the compiler? How many main phases? Okay, let's see who will answer that. How many main phases? Total 7, but out of them the phases which are main for the compiler. Lexical phase called as analysis, syntax phase called as syntax analysis, semantic analysis, intermediate code generation or generator, here code optimization, and the code generator, and then code optimization. So this is our whole syllabus 2. This is our whole syllabus 2. Anybody answered? Mainly we have the 5 phases. There are 2 phases like code optimization comes twice, that can be included as a part of the intermediate code, here code generator. So main phases are 5. The 2 phases code optimization can come twice, and that will become total 7. Okay, but if you try to understand right now, can you cope up with example? Because you do not know anything, then you are in trouble. So let me tell you, example later on after this. Let me introduce the concept first. If you look at all these phases need to connect or need to interact with symbol table. What is this called as? Symbol table. It's called as data structure, where it stores the information of identifiers. Any new name that you included in your program is identifier, like other than operators, other than the compiler predefined things. If you write your own names, then that will be called as identifiers. So all the identifiers, their information is stored here, and it will be interacted in each phase. Okay, but first time the symbol table is used by the lexical analysis, then others can modify and reuse the variables or data which you have. And another one, if any error comes, then there should be an error handler. Your compiler supports error handler, then it can handle some of the errors that you have written. Okay. So every phase of the compiler is going to use this symbol table. Okay, and every phase of the compiler is going to report some errors if any errors are produced. How many of you know what might be recorded here? So mostly the lexim information, like what is the type of lexim? It's a token type basically. So here the information may be dealt the token information. Token info means, is it identifier or keyword? What kind of information it is? If it is ID, definitely here ID information is there. So it's going to give you ID1, ID2, ID3, some kind of assignment. And here maybe syntax information, like line number, kind of information, and semantic information like type. What is that variable type is going to be assigned here. And in remaining places, the intermediate code, it's going to assign new names, or you're optimizing the code. Then there are many things which you are going to use related to the addresses, offsets. So here offset and addresses are going to be dealt here. And this side you'll be having lexical errors. Same token information that we call lexical errors. Here syntax errors, syntax related information, and semantic errors. And remaining all a fact that you can't avoid, any error comes from these phases. Okay, but these phases you can catch and you can understand, you can change the code. So if any errors happens from here because of limitation of the computer, maybe memory is very small, your RAM that you are using, right, hard disk and RAM, it's very small, then it's not able to support, then errors might produce from here. Fine. But there are no new keywords, Shifu. The keywords already compiler knows, so no need to store in the symbol table. Compiler can store something which is not known to the compiler. So identifiers are new that you are writing on your own. Compiler not aware, but it knows the rule, so it will identify what you have written, it will store in the symbol table. So keywords, no need to store in the symbol table. Of course you can store, but unnecessarily you are increasing the space, right? Compiler already knows you are maintaining it in the symbol table. What is the use? It knows int, it knows if, it knows for, then what is the use of maintaining them, right? Not required. But if you want to maintain in the symbol table, you can, but what is the use of it? Compiler already aware of the reserved keywords. Itself is called as reserved keywords. Okay. And there is another table if you want, literal table. What is the literal table? In lexical analysis, the literal table is any constant that you see, it can be stored in the literal table. And if 100 comes 1000 times, then 100 can be mapped to that constant place. Anyhow, that understand. So there is a literal table. Even strings, characters, integers, all of them you can maintain literal table here. Okay. Anything else? Now you wanted an example, right? So all the phases of the compiler requires the support of error handler as well as symbol table. And what is a symbol table? Symbol table is a data structure. What is it? It is a data structure. It stores information, that is attribute information of each identifier or each variable or each function. Identifiers are two types basically, many types of course. Each identifier, the main identifiers in C language or any language is a variable name and function name. Okay. Yes, the grammars are there, you can use them to design the phase. Actually these are the programs, right? You can use the grammar, but for what purpose? To design them. But these are programs. These are all programs, right? Lexical programs, syntax programs, these are all programs. You have already implemented them. It's executable code basically. Okay. So when you look at from overview, this is internal view, right? You give a C code. What happens? Which C code? Pre-processed. Then what happens? It takes the C code and collects tokens. So it produces token stream. C code is basically called as character stream. Character stream. It means sequence of characters. Token stream. And then it will produce some parse tree. Let's say it produces some annotated parse tree to understand the semantic. Then so far the C code you are trying to analyze. So you are analyzing till here. The same C code, now it converts first time to the intermediate code. And that intermediate code again produced as intermediate only, but optimized version. And this intermediate code converts to assembly code. And if any possibility of optimization, you can do here. Optimized version of assembly code. Right, everybody clear what is the output of each phase and what is the input of each phase? In a previous GATE exam, they asked identify the input of each phase. In future, they may ask what is the output of each phase. Okay. Table will not work. Table is the data structure. Table is what? Data structure. And this data structure will be used. And this is not a, it is data structure, right? The program, these are all programs. They will try to use this data structure like a stack, queue, arrays. These are data structures. Trees. So this can be implemented mainly with the help of arrays. Okay? Array of pointers, something like that. So now this data structure used by all of them as a part of the program. Right? Done? Anybody need an example? किसी को चाहिए एग्जाम्पल? फ्लैश 1 मिलियन एग्जाम्पल चाहिए आपको? क्या क्यों स्पैम करते हैं यार? Okay, let's take an example. Don't worry, what is it? Example you may not understand as you don't know compiler. Then if you know the compiler, it's very easy to understand. Okay. So now I'm giving some C code. Let's say which one? X is equal to A plus, let me take the bigger one because I need to do many things. Okay, this is my C code. So this phase is called as what? Lexical analysis. Lexical phase. Now what it does, it will keep the same code, but it will gather all the tokens. Now I have written X is equal to A plus B star C, but I can also write something like temp is equal to, something like ID multiply with what big names like XY plus C, something like that. Then what happens is going to do something like this. Okay, ID1 collected equal to ID2 multiply with ID3 plus ID4, something like that. The code will be converted into some unique form. So each one will be identified, all the identifiers will be identified, it will assign internal token name. So if temp is username, the ID1 might be the compiler name. So ID1 called as a token, temp is called as a lexeme. Okay, in lexical analysis you will understand it. Temp is the lexeme, ID1 is a token, but token lexeme there is no difference. For the programmer both are different because programmer cannot see what is inside the compiler, but compiler knows exactly what token it is going to be. Okay, it assigns something like that. And then this syntax analysis, what happened here? You might see there are a lot of spaces here. You might see lot of spaces. Let me write something like this. Temp space is equal to, and what else I can write? I, let's say I multiply with A plus B semicolon. So it does something internally like this. ID1 is equal to ID2 multiply with ID3 plus ID4 semicolon. So during this it might record symbol table. So there is a symbol table, right? For temp there is a row, for I there is a row, for A there is a row, and for B there is a row. So what happens here? It will record the information. Oh, it's ID1, ID2, ID3, ID4. So it is symbol table. This is what? Symbol table. Now it records the information of these attributes. Of course this is called as a lexeme, this is called as a token. Okay. In future maybe here in syntax analysis, that will be later, it might catch the line number or something like that if it wanted, otherwise not required. Let's say line number, let's say line number is 10, then everybody will record that line number is 10. So syntax analysis, what it understands, you have given the sequence of tokens to me, Here, there are no spaces, even semicolon after this is not required. After this, it is not required. I'll put a semicolon, but now this syntax analysis will understand this code. I need to produce this parse tree for this. So it will try to produce a parse tree. If it has, it is lucky. If it is not, then it will generate an error. So parse tree will be generated. What could be the parse tree? Something like that. Don't worry what is it. Okay. A equal to B, and A is some ID, and B is, let's say, ID star. Just wait. Don't worry. C plus ID 4 ID. C, let's say ID star ID. Some parse tree for this. Some parse tree will be generated for this. Don't know, because you did not see the compiler how it was implemented, right? It does something. How? Why? Because it need to understand the syntax. If I have a parse tree, that means this is syntactically correct. To understand this, it uses top down or bottom up parser to analyze this one with the help of the stack. So this requires a stack to understand it. This requires a stack to understand it. This requires regular expression or DFA to understand this. So lexical analysis needed a finite automata or regular expression, and syntax analysis requires the stack, mainly PDA or DPDA support. And then it will produce the parse tree. The semantic analysis, it is the same C code, but analyzed code, that is. The semantic analysis or semantic phase, what it does, it try to understand the type. So this type, there is a type, right? What type? This a temp is declared as integer, and I is declared as a character. What is it? So it's going to understand what type it is. If all are integer, it will record, because it is going to do that. It will record all integer types with the help of other, internal well-defined grammars. Okay, here it will record how this is a parse tree, right? This is a sequence of tokens, right? Sequence of tokens. But what you have given is just sequence of characters. Now what it does, it does something by having some internal rules. Here there is, to make an entry into the symbol table and to understand the type checks. So many things are there here. So it does some translations here. Okay, I'm not going to put here all these things, but it adds some translations to existing one. Okay, so just this bracket, assume it is some translation. Remaining, I'm not changing it. So same parse tree, but it is annotated, means decorated. What decorated? With the type information, or type checking information, or making the symbol table, or updating the symbol table. Many things are there. And now this intermediate code, what is this? Intermediate code generator. And this one, intermediate code generator. Okay. What it does, it is going to produce some intermediate code. Maybe let's say 3 address code example, 3 address code TAC, one example. Or you can generate syntax tree, you can generate a lot of things, postfix lot. So here it is going to do something. It's do multiply, I write ID1, this one, ID2 multiply with ID3. So here it's going to do something. So these IDs actually may have some names, but I'm using the same. ID2 multiply with ID3 will assign to some T1, and T1 plus ID4 will be assigned to, let's say, T2, and T2 will assign to that whatever ID1 you have. But this 3 address code can be optimized further, so you may need code optimizer. You may need code optimizer. So what this code optimization does, it will try to optimize. Why do you need this many variables? Can I reduce further? So ID2 multiply with ID3. So why are you storing in T1? Maybe can I store in ID2 again? Then ID2 plus ID4. I may use ID2 back. So the same ID2 I can use for as ID1, because ID1 if you has no job, then same location I can use. So I optimized further. Then this is code generator. What is it? Code generator. Code generator. What is this code generator should do? It should generate equivalent assembly code. क्या करना है? Equivalent assembly code. So one something like multiplication and other one is add. If you want to move somewhere, then move it. Then if it is possible to optimize, then it will do something. Okay. Code optimizer again. Code optimization. So what it has to do? Say if you don't need a move, then you can just implement with mul and add. That's it. No need to move. That's keep it as it is. So this is the final goal of the compiler. Now ask Asif in that chapter. This everybody is a chapter that one issue asked, sir, can you give me an example? What is the use of example when you don't know compiler? If you know compiler, you can understand. That's what I told, right? अगर आपको कंपाइलर पता नहीं है तो ये समझने आएगा आपको, बट इतना तो समझ में आएगा यार कुछ तो चल रहा है यहाँ पर. मतलब एक सीक्वेंस ऑफ कैरेक्टर से टोकन्स में कन्वर्ट हुआ, टोकन्स पार्स ट्री हुआ, पार्स ट्री अनोटेटेड हुआ, अनोटेटेड 3 एड्रेस कोड में हुआ, इंटरमीडिएट कोड ऑप्टिमाइज हुआ और असेंबली कोड हुआ और ऑप्टिमाइज हुआ. बस इतना तो पता होगा. ऑप्टिमाइज्ड 3 एड्रेस कोड, ओके, एंड दिस इज असेंबली कोड. This is optimized assembly code. Right. If you already know the compiler, this is not the big difficult, right? So this is our syllabus. So first chapter is lexical analysis. This is our first chapter. This is our first chapter. This is chapter 1. This is chapter 2. Here we don't study separately this, but in chapter 3 we will cover this. Chapter 3 everything is covered, and separately chapter 4. And this is chapter 5. And code generator we don't study much because its implementation is depending on the machine. Clear? These are our chapters. And everybody may involve with this symbol table. Here there are no questions here. We have from the first chapter lexical analysis. Theoretical question, what do you need? Patel, questions will be coming from here only. What is the output of the semantic analysis? What is the output of syntax analysis? Why do you need the question theoretically? Correct? Come on. क्या questions पूछ रहा है यार? Done? Are we ready to start the first chapter? But before that, let me give you conclusion of the phases of a compiler. How many phases are there? Lexical, syntax, semantic, ICG, code optimization, code generation, and code optimization, right? If you look at this, till here, these are machine independent. These are machine dependent. So you can implement a compiler using 2-pass compiler. So first pass, second pass. So compiler mainly, most of the compilers today, they are 2-pass compilers. First pass they will work up to here, second pass they will work here. If it is a 1-pass, right, everything is in one program. So you can break the program into 2 parts. You can break clear? Now here आप डिस्कस कर लेना यार, जो भी अलग डिस्कशन चल रहा है. और जो 3 है इसको बोलते हैं एनालिसिस फेसेस. analyzers. जो रिमेनिंग बात होता जो मेनली आईसीजी एंड सीजी, इसको बोलते हैं हम सिंथेसाइजर्स, राइट. सो ये जो इंडिपेंडेंट एंड डिपेंडेंट दिख रहा है ना, इसको बोलते हैं हम टू पास कंपाइलर. बेसिकली टू पास. अगर वन पास है तो ये ब्रेक करना जरूरत नहीं पड़ेगा, एक पास में कर सकते हैं आप. टू पास कंपाइलर कैन ब्रेक दिस होल प्रोग्राम इनटू टू पार्ट्स, टू मॉड्यूल्स. एक मॉड्यूल में ये 5 इंप्लीमेंट कर सकते, दूसरा मॉड्यूल में है. ओके. All right. Done? अब तक सभी को समझ में आया? कोई डाउट है अब तक? इज देयर एनी डाउट? क्लियर? ओके, ग्रेट. So एग्जाम में कोई भी theoretical question यहाँ से आया, any theoretical question that you see from here, so please answer properly. Okay, in exam they may ask what is one, not exam, interviews, what is one pass compiler, 2 pass, 3 pass, 4 pass, even 6 pass also you can implement, because that depends on how many phases you want to keep together. 2 pass means you are dividing the whole compiler into 2 parts. Then there's a one part and second part, something like that. Okay. So these are the two phases, 2 passes, analysis and synthesis are 2 modules. You can say that. If you really want to implement other way, 2 pass, you can keep this is in 1 pass, other pass. But that depends on how do you implement. Okay. So we have so many pages like what lexicon analyzer does, what syntax analyzer does, what semantic does. So far whatever I've explained, right, the same thing is there. So there are many code optimizations on what is a symbol table and everything what you have that we will see in the coming chapters. So are we ready to go for the first chapter, lexical analysis? Yeah, because to understand it first the code generator should be machine dependent, because how the code generator knows assembly code need to be produced. Assembly code depends on the machine, right? Assembly code depends on the machine, right? Machine to machine assembly code changes, right? Then code generator is also fixed to the machine, because code generator knows what should be assembly code, right? If the code generator is not there within the machine, then it can't understand what assembly code need to be produced. So code generator itself should be machine dependent to produce the machine dependent code. Is that clear, everyone? That is the reason whole compiler is the machine dependent, because of the last phase, because of the last code generator, and whole compiler is the machine dependent. Okay. If you can divide the compiler into 2 parts, then only the second part will be the machine dependent. Ready? Any other doubts? Theoretically, if you have any doubts, ask me, because your questions might be valid. Right. No, don't ask Java, Java, see these things. Object code everywhere is different. Don't ask object code everywhere. Some information, Shifu. Ready? I didn't get you. Get easy. Manjit, we are only talking about C, not Java. That is integer is not a keyword. Oh, Manjit, you studied wrong. The Manjit question was something like this. Integer. It's not a keyword. Integer what? Some x. This is not a keyword. This is assumed. This is no syntax error because compiler cannot detect as a syntax error. Semantic analysis will catch it is a semantic error because the integer is not keyword. If I write typedef int integer, then this C program absolutely works correctly. So because of that statement is missed, the semantic analysis will catch that, oh, integer has to be type, because these two are in C language, these two are treated as identifiers. But this one is not identifier if you have this statement. The semantic analysis will replace with this as a keyword, integer, right? The compiler can understand this integer is an int because it can understand in the semantic analysis. Till semantic analysis, it has no idea integer is int or identifier. So understand, in semantic analysis only, this statement will be identified as int x. That is the reason this program has semantic error, because of this line is not there, but it's not a syntax error. Oh, they did not ask Java, they asked C only. It is a C code only, but you are misunderstanding it is Java. It is not a Java error, it is a C. Okay, fine, clear? Got it? All right, any other doubts you have? Because our mind is unexpected, unpredictable thoughts might have, right? If you have any unpredictable problems, you can ask in the chat. It is the character stream. Character stream means what? It is a source code. Source. This is token stream. And if you have any error, it will produce lexical error. It can use a symbol table. Okay. The one thing we are not discussing, you can also interact with the parser at the same time to separate the tokens. Yeah, it uses, right? When you are including more programs, it can use more memory too. Now, when somebody writing the code, let's say void main, very simple program, I'm trying to do it here. Int x is equal 10. Then what happens here? This will be converted into tokens like void is token 1, main is token 2, token 3, token 4, or maybe token 5, and token 6, token 7, and token 7 is repeated, and token 8, token 9, and semicolon is already coming. You can remember that 1 2 3 4 5 6 7 8, 3 4 5 6 7 8, token 8 is coming again. Did I miss anything? Just wait. 1 2 3 4 5 6 7 8, T7. Oh, semicolon is missing here, I'm sorry. There's a T8, and here T7 and T9, T10, and semicolon is coming again, that is a T8, something like this. Don't worry, what is it? T11. Okay, I don't know what is it, but compiler knows exactly how this is going to be converted. See, do you have any spaces? Compiler clearly knows. Here you don't need even what the spaces, comments, anything. It just knows it is just one sentence, one string. Can you see that? This is just like a one string. So syntax analysis will take this one and will convert into the syntax tree, because it's just a program. It's just like A, B, C, D, E, F, G, something like that, right? This whole program is converted into one string. This is called as token sequence or token stream. And here this will be treated as like T1 and T2. Of course, T1, T2 might have different names. I'm not writing all of them, okay? T3, T4, and this is T5 and T6. And X is T7. If it comes again, it will detect somehow using its own logic. Okay, it's a T7. And T9, new token, and constant T10. And semicolon is having unique name, let's say T8. And this is, let's say, T11. So total you have how many tokens? 13 tokens. So total you have 13 tokens here. They may not ask distinct tokens, all these things, very confused. So they ask how many total tokens recognized or produced during the scanning. Everyone? What a symbol table is one small topic. Are you implementing symbol table? Why do you have a confusion? Have you looked any time symbol table at all? Come on, Pooja, why do you have a symbol table? Symbol table is a very small, and you are not implementing symbol table, you are only learning. Symbol table is a data structure. You know what is a data structure? Data structures can be different types, stacks, queues, trees. So this can be implemented mainly with arrays or trees or hashing. Have you implemented any time? No, right? We never use a symbol table theoretically. Compiler uses it. You are learning how compiler uses. So now the symbol table is going to use this. Okay, it will create the symbol table. I am showing the symbol table also. Here symbol table require for the main one entry, for X another entry. So that's it. Main is, let's say, what token you have referred T2, and X what token you have referred T7, and what is the line number? Let's say this is a lexeme, and this is a token, and let's say line number is not now, syntax analysis will take care, and type we don't create now, the semantic analysis will take care. Symbol table is going to make entries for every identifier, and remaining every identifier you have some attribute information, like DBMS attributes means column, right? For main, so many properties are there, like its line number, its token type, its offset, so many things are there. What is the corresponding address, what is the corresponding register, so many things you might assign. So in future it will be modified, okay? So anyhow, try to understand. It's very simple. Symbol table is a data structure that stores each identifier along with its attribute information. It is used everywhere. Have you missed the first page? It is used everywhere. It's used in every phase, right? Go back here. How do you use it? Why do you want to use everywhere? The question is only about symbol table, right? They don't ask how the symbol table used in intermediate code generation, how the symbol table used in code generation. That's very complicated. We are not going in detail that much, okay? But really, if you want, you can learn, okay? So mainly you focus on lexical analysis, how the symbol table is used, and later on we most not study how the symbol table is used. But you can study in compiler, because compiler is so big. But for the GATE exam point of view, so far I have not observed any such level of questions in GATE exam, okay? Yeah, you should know what is the limitation while studying. If you don't limit right, you symbol table only will take 1 day to study. Okay. First, not started, Annie. We have not started token also. What is token also not started properly? I'm only telling what is the lexical analysis. Lexical analysis will take the C, so C program or C++. Let's say C only. We are talking about C, right? So it scans the whole code and converts into the sequence of tokens. That line I want to say, for that I have taken example. The lexical analysis is not yet over, not yet started. Just we are beginning, right? Clear? Do not go very advanced. That's why I told our brains are unexpected, unpredictable, and it will think anything that unrelated things. What sir is teaching, what you are thinking, what you are asking, is it matching? When it matches, you will enjoy a lot. Everybody clear? What I am teaching and what you are thinking and what you are asking, if the three are connected, then for me, for you, you will never have any issue. Ask the questions from here. And if I don't teach, I'm going from the next topic, ask back. I'm coming back also, right? I never go, right? Even you are asking future. Somebody asked integer, that comes in semantical. Still I explained, right? So when time comes, definitely I'll explain. But if anything, you have an issue here, focus here. Present is more important than the future. But past is so important to connect with the present. How to stop unrelated thoughts? Very good question. I need to be, trainer for the psychological, right? So your thoughts. Mostly while you are studying, if you are not in control, use the pen and paper. And mostly focus on what I am writing and try to write some time so that you do not think anything else except this. So use pen and paper, and what I am teaching, just put in rough format or in clear format is your choice, so that you will be here only, not in any movie or not outside. Correct? Shifu. So thoughts can be controlled by our external or our body only. A body can stop, but you need to utilize it properly. Okay, all right. Now, everybody got what is the lexical analysis? What is the lexical analysis? What it takes? This character stream. Character means sequence of characters here. It means source code, pre-processed source code. It produces output as token stream, sequence of tokens. But very big job, not easy job, I was explained very easily, but it was not easy. Why it was not easy? The spaces need to be deleted. So do you see any spaces here? No. Here there is new lines, white spaces, so many white spaces. Here so many comments. So comments and white spaces is job of this scanner. So this lexical analysis also has a lot of names. Scanner, linear phase. So many names are there. So this need to scan and it need to ignore. So it recognizes tokens, but using some technique. By grouping, it recognizes token every time. By grouping characters, one or more. By grouping characters, but it's not alone. With the help of some technique, with the help of many things, with the help of maybe parser need to help during this second. While grouping the characters, right, it might use the longest prefix rule. It will use, no doubt, longest prefix rule. It might use token separator may be like white spaces. Whenever the space comes, it knows that, oh, token is completed, one token is generated. White spaces or comments, so many things happen. It not only recognizes, it ignores many things. It ignores the white spaces and comments. Not only this, it produces lexical error, if any. And this can be designed, of course, practically this takes much time, right? If you want to design this, you may use a finite automata or you may use a regular expression, and it can use a symbol table to store the attribute information. What else it can use? It uses or it stores token information in symbol table. Which tokens? Mainly identifiers. Right. This can be designed. It can be designed with the help of TOC. Which part of TOC? TOC in that regular expression or finite automata or regular grammar. You can use any of this to design this phase. So any theoretical, I have just written, right? I'm going to talk about, right, what is the longest prefix rule. I was just writing theoretical points that you should not miss any point here. Okay, I'm going to talk about what is you don't understand from here. So to understand this, first you should know what type of tokens we have and what is the longest prefix rule, and of course remaining you know the white spaces, comments, everything, you know it. So how this lexical analyzer groups characters into tokens. How it groups? Yeah, I say that it groups characters into tokens, but how it groups, that means you should learn the longest prefix rule. That's second. And what is the token? What are the tokens are there? So two things need to be clear to get the idea of these definitions. But of course, assume that is something rule is there to use it. Okay, we'll see that later. Everybody clear? What is the lexical analysis? It is a program, no doubt. What is it? It's a program only. Don't assume it is anything else. It is a program. Or part of the program. If the compiler is a whole program, it will be the module. It will be a small program. Correct? Any doubt here? Except what is the longest prefix match rule? Any doubt? We'll expand this concept. Okay, to understand these points, first, okay, anyhow, you study this yourself, all the things. Okay, now you see types of tokens. This is what I am talking about. Types of tokens. We have identifiers, keywords, operators, and some constants, literals, special symbols. 5 types of tokens are there. How many types? 5 types. So during this scan, you need to group, but that group must match with one of them. So example, I have void. See here, V is there. V is character. What is that? Character. And look at here. VO is a character. VOI is the character. Sequence, right? Sequence of characters. Sequence of characters. But which one is the token? Is that V is the token, or VO is the token, VOI is the token, VOID is the token? Which one is the token? Right? V is looks like identifier. This is identifier. This is also ID. This is also ID. This is keyword. But all are correct only. All are matching with one of the tokens. Then what is it? Which one is the correct? So now we need the longest. So who is the longest? This is the longest. This is called as longest prefix. This is called as the longest prefix rule. Void is called as longest prefix word. That's why we generate void as a one token, not 4 tokens here. V, O, I, D. 4 tokens we don't generate. We generate only one token. Is correct? This is called as longest prefix match rule. Okay. Everybody, that's why void is 1, main is 1, and open parenthesis is 1, closed is 1, int is 1. We didn't say int 3 tokens, we said int is 1, right? So longest. When you see something like this, main, main, so here main is the 1, mai is 1, looks like valid token, but this is the longest. So main is we consider as a 1 token. Everybody, but anybody writes ma space in, now it will be 2 tokens. Right, this is the longest, this is the longest. We will be having 2 tokens because space comes for separation of the tokens. Spaces or any punctuations you will use that can be used as a separation, basically, like semicolon. Can we separate the tokens? Even semicolon itself is a token, of course, that 2 tokens. And space is not a token, look at that. Space is not a token. Space never comes in any of them, okay? 1 token, sorry, 2 tokens, Nishu. Because the lexical analyzer will not have the knowledge. If you do something like this, A, right, then 1, 2, 3, total 3 tokens here. We'll learn that slowly, right? It will not understand balanced thing in the lexical. So later on, parser will come into picture, and this 2 will be kept as a 1, but that's not a token, that's something else. 2 square brackets, if you take, it is a 2 tokens, not 1 token, okay? It has no memory, basically, it has no memory. It has no memory. I'll practice it, right? I'll practice it. Okay, if anybody want to implement, so today we use lex tool, you know, example lex.yy. is something like that. So in practically, if anybody want to implement lexical analyzer, you need to use the lex tool. There are many other tools like Unix, Windows, there are 7 different tools are there, you can use them. But in Linux also there are various versions are there. And if you really want to implement, you can use regular expression, DFA to design the lexical analyzer, do design. But how you design, that takes much time. Okay, are we ready now? Now we know 5 types of tokens. When you use the word internationalization of a compiler, what do you mean by that, yaar? Give me the functionality, I'll tell you, is it you are using for natural language processing? Yes, correct. Space is ignored by the compiler, but to ignore it, it has to understand. Ignored means it will not count as a token. Understand that, Verma. Ignored means it will not count as a token. It has to ignore. It has to it should not count. That's what I told, right? It ignores white space and comments means it deletes. It avoids in counting the tokens. It ignores white space and comments while counting tokens or while producing the tokens. Because this is what I'm saying, this is not a token. That's what I'm trying to say. This comment and white space, not tokens. They should be ignored, but they will be considered to separate the tokens. There are many things here. Okay. Come on. Okay. Let's start. How many tokens we have? Are you trying to implement lexical analyzer? If you're really implementing the lexical analyzer of compiler, you spend 1 year, you will get all the logics, what exactly you want to do with the white space. Okay? Void, main, okay, this is, you know, open and close. Actually, it looks like combined, but not. Okay. So how you count the tokens now? That's a gate model question. See, it's 1, right? 1, 2, 3, 4, 5. and 6, 7, 8, 9, 10, 11. So now why that 8? The gate is one token. While it is grouping, what happens? The lexical analyzer knows, oh, double quote. It means the string constant is started. It will wait for the end. So everything is considered as one constant. And if you look at the token types, one string constant is a one token. Everybody clear? Those people who are not aware of this point. Okay. So here you have 11 tokens. Next. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. So those people are able to answer 18, they are correct. Yeah, most of you answered 18, that's great. So don't answer. Star P is actually 2 tokens because star is operator. Token type is operator and P is identifier. Star P is not having any meaning at all. Star P is not a one token, 2 tokens. Remember that. This is 2 tokens. Star P we used for dereferencing pointer or declaring the pointer, something like that, right? But this is not a one token, 2 tokens. Okay, please careful while you count it. Because the lexical analyzer is not going to check the balanced open, close, open, open, no knowledge, no knowledge. It will not use any stack. Syntax analyzer will take care of open, do you have the corresponding balance? So this matching will happen in syntax analysis, not here. If the lexical analyzer will not identify as 2 tokens, then syntax analyzer will have no knowledge to check is it balanced or not. So here the open, close, if you consider as 1 token, syntax analyzer has no job to check this one. So it's a balanced parenthesis, need a stack help. The stack, it will be used, open you will push and close you will match to check the balanced parenthesis. You know, right? To check the balanced parenthesis you need a stack. But this lexical analyzer is not having memory at all. It uses just states to understand, right? Moving from here to here, that's all. Okay, what else? Where are we? Int x 3, 4, 5, 6, 7, 8, 9, 10, 11. So how many answered? It is 11. Next, 1. What is it? What is it? Error. So now here you started with 1, right? But here you see that 1x, after 1, no space is there, directly x is coming. X1 at least you can assume right, valid. But what is 1x? 1x, if you try to understand 1x, then no space is there to separate, and 1x is not identifier, not a constant, but x1 is identifier. That can happen. This is identifier, but 1x is not identifier. So 1x is invalid sequence called as. So this will generate lexical error. Don't count it all. Which one you want to explain here? Here only the problem is star p is there, ampersand x is there, x plus plus. Already I told star p is 2 tokens, ampersand x 2 tokens, and plus plus is the 1 token. This is the 1 token using longest. But ampersand x is the 2 tokens. Only this 3 is an issue. Here there is no issue, right? You can count all of them clearly. Who is having an issue to count this number 2? Only this 3 you may have an issue. I'm already clearly explaining type star p y 2 tokens, ampersand x y 2 tokens, and plus plus is only 1 token. Count this 3 properly. It's done. Correct? Yes. Right. Done? Perfectly all right. Keep going. Okay, take time. Okay. Answer it. I'll be just checking. I'll have water and I'll come back. So anybody answered correctly so far? One, two, three, 4, 5. Total 5. 1, 2, 3. Now it's open and there is no end, so this will generate lexical error. And what is the lexical error? You opened it and there is no close, no end, so this will give you lexical error. Okay, and now you see 1, 2, 3, 4, 5, 6. Here it is 6 tokens. Okay, now there is an issue. 1, 2, 3, 4. Here, when you write two single quotes together, right, it might be considered as a space, the character constant, or it's a beginning of the string constant. If it is the beginning, then it will look for the end. Everybody, if it is the beginning, it will look for the end. But if it is assuming that you should write, so when you write together, right, when you keep together, this can be considered as a character constant also. That can be considered as a character constant also. Here, there is a misunderstanding of the syntax. So here, the possibility of error, because invalid sequence is coming, because this between these two, no space at all. And if you give the space, there is a chance of identifying valid tokens. So after double quote, you don't have the space, so it cannot be considered as a single quote. What is that? A character constant like this. So yes, the space is there. Now there is an issue with this pattern completely. So please check it. Of course, I cannot go into the lexical analyzer to edit it. So I'm just saying it is a compiler error, but lexical error also present here due to invalid sequence. But if it is not having lexical error, it is an implementation problem or implementation specific. So here compilation error is there. For exam point of view, lexical error is not important. For that it is fine. These things are very complicated. Because of the rule, end quote is missing. But before that, when you have only this is actually considered as a character constant. Because when you start, when you close it, it will happen like that. Okay, but when you do one more time, then this will convert automatically like this. So there is a problem with the system understanding. So here I'm just saying lexical error, or it will be compiler error. Syntax error definitely there. I'm just mentioning it. Some things you cannot understand because like compiler has to say exactly how it is to scan, right? Some of the lexical errors can be ignored because syntax analysis will take care of it. Okay, this one I'm just leaving to you, and no need to practice this as it is implementation dependent basically. Yes, definitely error is there. 1, 2, 3, 4, 5, and see here you started the comment, but it's a multi-line comment. It's never coming, right? No end of comment. No end of comment. No end of comment. This makes the lexical error back. Yeah. Which one space A? No, there is no meaning. No, this has no meaning. But this has a meaning. Of course, it will not happen. It will happen like this. So when you write two single quotes together, it can be considered as a character constant. It can be considered as a character constant. Its writing is very difficult for me. So this can be considered as a character constant. Right? Character constant. You can, when you give like this, it can be considered as a character constant. But when you give like this, no meaning to it, right? So here, this will never be valid even you give the space. But after double quote, if you give the space, this may be considered as a character constant. So this is very important. Okay, single quote space, double quote space, lot of differences there. That's why sometimes we do not understand how the program is executing, compiling at least. No, will not calculate the tokens, because in that line you have an error, right? Compiler may compile whole thing, but you need to ignore this so many things here. You don't understand what's happening at all. The syntax error only you will face, because that kind of thing not there in the syntax, right? Syntax only you will face an error difficulty. If the lexical error will not catch this, then syntax error only. Oh, gate is coming, that id is coming after this constant, so constant id cannot come together without any operator. So here like syntax error only will catch that error. Okay, do not worry about the 8. If you want, really analyze yourself, okay, but don't worry about it. Any doubt you can ask, I'll explain, but if you don't understand, better to ignore the 8th one. The masters is something different, it is related to the networks, but PhD topic is this one only, bug finding. Okay, finding the errors in the programming. That was the, okay, how many programs are over? 9, right? Okay, so this slide is something difficult, different. You need to identify exactly what is an error. Of course, number of tokens you can find. So now we are going to work on whole compiler. So many people know about C programming, right? So first here, count number of tokens. If not possible, tell me lexical error. If you count tokens, tell me, do you have any compilation error? Yeah, I need to know exactly which error. So I'll give the time, lexical, syntax, semantic. Identify which error happens, apart from finding the number of tokens. So now you have two kinds of questions, guys. I think at 9:30 we'll take a break. So you can have dinner and can come back. Eleventh, see, error might be there everywhere. I don't know exactly. Assume this is written in the main program. That's all. This is the only line is written in the main function. So now tell me what error is there. lexical error, syntax error, semantic error. Lex, syntax, semantic. Okay. So which error it is? First one, no error, everything is fine. So no error, no error, no error. How many tokens we have? 1, 2, 3, 4, 5, 6. 6 tokens. Here 1, 2, 3, 4. No error. 4 tokens. But do you have any error? No lexical, but int is equal 4. Keyword is equal keyword. That is right. Then you don't worry. Once you get a syntax error, semantic error will be there, no doubt. So we'll just identify earliest error that is detected during compiler. So once this error happen, we'll never talk about semantic, because obviously it should happen because of syntax. There is no meaning to the semantic. So don't worry about this when I choose this. Okay, we need to find the possible error detected. Now here x, y semicolon, x, y semicolon. How many tokens? 3 tokens. 3 tokens. Lexical error? No. Syntax error? No. Here it has happened semantic error. Why? Because x might be integer if the type def exists. The semantic will check is that x is integer or character or what data type or not. But x is not understood by the syntax analysis. So syntax analysis will pass it because it looks like proper syntax. It is proper syntax, but it will have a meaning or not, the semantic analysis will decide. Will have a meaning if x is having type def. So here there is no type def, so here you will get an error. Okay. So now int 2, 3, 3 tokens are there. How many tokens? 3 tokens. So no lexical error. And this one, after int, the constant is there, but we know there should be variable, identifier should be there. So the syntax will not allow int constant, this int, this kind of, right? So here error will happen, so that we don't care, right? We need identifier here, int identifier semicolon. So that syntax is there. In case if the syntax analysis is allowing keyword constant, then you should be very careful. Okay, in my knowledge, there is no such syntax. The keyword constant semicolon. If anywhere that happens, then this will also be passed. Okay, in my knowledge, that syntax is not there. Okay, int 2 comma 3 semicolon, right? So whenever int comes, right, the compiler knows there should be identifiers. If you want constant, identifier is equal to constant is fine, but only constants is syntax problem. 1, 2, 3, 4, 5. 5 tokens. No lexical error, but syntax error. So when there is syntax error, don't talk about semantic. We know it will happen. 12th repeat, please. Well, that's what the gate question. That was the gate question. So that's the problem, right? X, Y. If this is the syntax error, no program should allow. That is the meaning. If this syntax error, then in whole world, whole C world, this is not allowed. Right, but it is allowed. I'm trying to prove it. See that type def int x semicolon xy. See this in this program. This is the valid program. That's why this is syntactically no issue. The problem with the semantic, no issue with the syntax, because other programs are taking it. If this is syntax error, this is also syntax error. If this is syntax error, this is also syntax error. If you don't allow here, you should not allow here also. Got my point? So I'm repeating 12th. Okay, so no issue with the syntax. How do you know that? I see the below. No issue with the syntax. Syntactically correct syntax, because other programs you are able to write it. So now you see this program, because the problem is here x and y are not having the type. That is how it knows that, oh, this is the semantic error. It will not know x should be integer, y should be integer. It will just catch, oh, x there is a symbol table and y there is a symbol table, and you have not made any entries into the type. So this is a blank. This is a blank. So now semantic analysis will catch, oh, x and y types are not assigned, it means, oh, this is a wrong syntax, sorry, semantic. So you don't have a semantic, this statement is semantically incorrect. Syntactically correct, but semantically incorrect. Okay, so understand, that's why this is going to give you semantic error, but it will not give you semantic error if you have this kind of, statement. No problem, no semantic error here, because x is already int. That is the reason y will be assigned with integer in the table. Got it? What about this? 1, 2, 3, 4, 5. 5 tokens. 5 tokens. So no lexical error. Whenever you are able to compute the tokens, no lexical error. Syntax? Oh, no syntax error. Proper. But semantic? That y is not declared. Y is not declared. That's why you have an error, semantic. Correct? Next. 1, 2, 3, 4, 5. 5 tokens. So no error, no lexical. Syntax? The syntax looks like proper. Int x is equal to some constant will be there. This is a constant. Address comes here. But while semantic analysis, if you don't have any implicit conversion, this will be address, this will be integer. So if, right, address and integer, so the compiler do not allow, you will produce semantic error. Only when the implicit type conversion is not allowed, you will get an error. If it is allowed, it will give you warning. So warning or error, the semantic analysis will decide. So this will be semantic error, because this will return address. This everyone knows, right? String means address of the first character. By definition in C language, string constant, you are passing to somebody means string will not be passed. Address of the first character will be passed. Now 1, 2, 3, 4, 5, 6. 6 tokens. Now this kind of syntax, did you see anywhere? Keyword comma keyword comma keyword? No, right? This is not a valid statement in C language. So even though it is not lexical error, but syntax error is there. So definitely semantic. And this one, keyword is equal. This syntax is not allowed in C at all. But 1, 2, 3, 4, 5, 6. But lexical analysis will not understand this thing. Only it will group and generate the token. Now that's why no lexical error, but syntax. 1 equal to 1, 2, 3, 4. 4 tokens are there. No issue with the code for the lexical. For syntax, oh, LHS is equal to RHS. That's also fine. No syntax error, but semantic error. Why? Because this one should be, this L value is expecting some location, but this is not location, it's a constant. So 2 cannot be assigned to 1. 2 cannot be assigned to 1. You know, right, in C language, in mathematics you can write, this should be some variable. This should be defining some layout. So x is equal to, y is equal to, a is equal to, right? Somebody should be there, but this one is actually referring the constant. So 2 cannot be, L value is required. What error comes here? L value is required. The L value is not expected 1. And 20, 1 double equal to 1, 2, 3, 4. 4 tokens. Double equal to is 1 token. And no lexical, no syntax, and no semantic also. Semantically is also correct, because 1 double equal to 2, the logically it is a false, so 0 will be returned, but not assigned to anybody, it's fine. Right? If you have any issue with these programs, please let me know. Correct? 20, no error. Semantic error also will not happen. 1 equal to is correct statement. You can execute that code within the main. You know, right? You execute this code within the main, nothing will happen. It will return 0. You are not assigned to anybody. It's fine. No error at all. No error. This is a valid expression, valid C expression. You can write anywhere in the C program like this. You go and execute this code in C program, right? Online compiler is there. Just execute. Will you get it? Program execute successfully. Right? So with this, the important things for the logical operator, that is, you can write that code. How many of you know? 1 plus 2, 1 semicolon, 1 double equal to 2. What else? that you don't ever expect that things at all. Semicolon. And if you're writing these lines right, will C program execute or not? Let me know. Will it execute successfully? Will it give any error? I'm just checking. Do you have any error? Do you have any error here? All are valid expressions. All are valid expressions. No error. But nothing will happen. That's what the problem. 1 plus 2, 3. But not assigned to anybody. Executed. 1 executes, but nothing happens. 1 equal to evaluates. 0 will not assign to anyone. Semicolon executes. Nothing happens. No error. So this is correct program. So code optimization will understand, the compiler will understand, it will convert to just void main and it will delete all the statements because they are all useless statements. Okay. Can we take a break for parsing? Like one by one. Every chapter will take one break. Because dinner time, right, for everyone. No error. Manjit Singh. 2 semicolons are right. Semicolon you can put anywhere, anytime, any number of times. Semicolon represent end of the statement. Manjit. If compiler is intelligent, it will not allow you. But semicolon represent end of the statement. It's okay. You can execute and check, right? Not online compiler, check local compiler. 20 minutes, we put 2 semicolon after a statement, then it gives error. You think as just execute and come back, Manjit. Go and online compiler, tell me, let me know what you see. Okay? But execute on different compilers too. For me it is no, but if compiler gives, then I can't help. 30 minutes, yes, we'll meet back by 10 p.m. Okay? We'll resume the class at 10 p.m. No, that's what I'm taking the break. Okay, Satya. Yesterday I did not take. How many of you don't know, right? So I did not had dinner yesterday. Yeah, that is the reason today I'm taking specially. Bye. You're welcome back. Are you back, guys? Yeah, in parsing, we have 2 types of parsers, top down and bottom up. So what is important for the exam point of view? Exam point of view will be focusing on without backtracking and that too non-recursive descent parser. This is our focus. Okay, and then we'll be learning LR0, SLR1, LELR1 and CLR1. There is one more bottom up parser, that is operator precedence parser. Okay, We'll be learning how to find the operator precedence there also. So if you look at overall, what is important in this syntax analysis? Okay, learn clearly the LL1 grammar. What is it? And learn computation of the first and follow. First and follow. And know how to identify ambiguous grammars. I just take the heading ambiguous and unambiguous CFG. And know how to build LL1 table. Know what is left recursion. And know what is left factoring. And no relation between what? The closure and the go to computation. Closure and go to functions in bottom up parsing. And the relation between like LR 0, the SLR versus LLR and versus LR, that's CLR. Okay, I think this is the most important topics for the exam point of view. If you see any gate question, right, there is another model gate question is operator precedence finding. Operator precedence, how to find it, correct? You see all the parsing gate questions, the questions lies here only mostly. Identifying LL1 grammars, or identifying that LR grammars, or computation of the first and follow, or filling the LL1 table, or questions related to operator precedence finding, or closure and go to function, or identifying ambiguous and ambiguous CFG. So you expect that 90% of the gate questions from the parsing will stay here, and maybe more. Yeah. So anybody is yet to come back? Are we ready? Okay, what was your lunch pack today? Sorry, dinner pack. Yeah, Manjit, that's what I told, right? Semicolon represents end of the statement, okay? Yeah, compiler able to understand it, that's good. Add fruits, Shifu. Sure. Mostly common, right, for everyone, roti with aloo chole, paneer. Adds fruits. I can't depend on the oil food, right? So all right, let's begin our session. So you look at any parser, right, which looks like DPDA. So of course the compiler follows the DPDA construction for the parsing at least. So those people who know, who are aware of the C, C++, Java, right, their syntax analysis is implemented with the help of DPDA only. Especially in the DPDA, they use LELR1. So whether you go for top down or bottom up, among them the LELR parser is very popular. LELR1, LELR, this parser, right? Is one special parser, look at LR parser. So this parser is used in general in many of the compilers today. That's a very popular bottom-up parser. Popular, not powerful, remember that. That was enough, or that is enough to represent our syntaxes in the programming languages. Okay? So how, when you look at this, right, this looks like what? Our push-down automata. So we have a program that is converted into tokens, and we have the control, mostly like using the stack. It uses a stack. Of course, this is whole picture is just looks like a DPDA. Whole picture looks like what? DPDA. But the extra you have the table. This table is going to have the actions or grammar representation. So this table you need to understand for LL1, for LR, what is that, and this is going to use a different approach. This finite control is algorithm basically. The algorithm is going to be either LMD or reverse of RMD, depends on top down, bottom up. First let me explain the difference between the top down parser and bottom up. Top down parser, if you use the top down parser, how the syntax analysis be designed. Bottom up parser, can you tell me some points? आपको पता होगा कुछ points, कुछ explain कर दीजिए, or statements. The first point, what derivation it follows? Derivation, how it derives basically. What derivation it follows? How do you derive here? To derive a string, what is the approach? Derivation means how do you verify the syntax here? This was a gate question already, right? This was a gate question for, okay, that's very easy to answer. What is it? Here you follow LMD. LMD means leftmost derivation. RMD, it's not RMD, it's RMD in reverse. RMD in reverse or reverse of RMD. Okay, first you need to find RMD, then do the reverse. Of course, theoretically, practically you have an algorithm directly. Second, what is the default parser that we use here? Default parser. Here also we have a default parser. If anybody asks bottom up parser, which one you come up with? If anybody asks top down parser, which one you will take consideration? LL1. Here you will use CLR. It's also called as LR1. Okay, both are same. Default, by default, we use here LL1, here by use of, in programming we will use LLR1, but by default for bottom up is CLR. Okay, but that is a very powerful, that's why we use here LL1. If anybody asks what actions you perform here to understand, actions or operations, whatever you say, to derive a string, what kind of actions you consider if you want to verify the syntax here? What actions you do if you want to verify the syntax with the help of this parsers? Anybody? Here mainly we do predictions, like substitutions. We call here predictions. Here we have the shift and reduce. Shift and reduce. Yeah, shift and reduced or reduce. Here predictions, because you need to substitute, here you need to reduce. So here the main thing that is here called as substitutions. What is the main thing that you do here? Substitutions. To do that, you do predictions. Here fourth one, here do reductions. That's called as reducing, right? Reductions. To do this, you need to perform shift and reduce actions. Okay. A conflicts we have, that's while verifying, right? SR conflicts, RR conflicts. Here you will be having the T and N conflicts. Okay, if anybody want it, but it's not disclosed outside, you cannot understand. Here while constructing, you will have the conflicts, but not while verifying the string. Remember that. While construction, that's why I am not including anything here. Okay, conflicts are not for verifying the syntax. It is while designing the parser. Okay, whether you are designing a correct parser or not. For that you will be having conflicts. If you have the conflicts, you will change the grammar and you will do proper designing. Okay. Are we ready? SRRR conflicts, that is for designing the parser, not for verifying the program, verifying the syntax. Okay. So mostly we'll use a table approach for all of them here. So we say non-recursive descent technique. Yeah, you can't say that. But if you are using this parser, definitely CLR is more powerful than LL1. Okay, you need to use the specific names, which bottom-up parser, which top-down. In general, if you take the powerful bottom-up parser, powerful top-down, definitely bottom-up is more powerful than this top-down, definitely. But if you are using LR0, you can't say LR0 parser is powerful than LL1. You can't say that word because no relation between them. Okay, you should be very careful. Some of the parser will not have relations, but in general, if you take powerful bottom-up parser, that is definitely powerful than your powerful LL1 parser. Okay. Let's look at what is LMD and RMD. Okay, my program is DBAC. This is my program. Tokens, 4 tokens I have, 1, 2, 3, 4. These are my sequence of tokens. These are my sequence of tokens. Now, what is LMD and what is RMD? A reverse of RMD. I hope you should know, right? You are aware of this, right? What is LMD approach to derive that string? This is your input. Can anybody? You will always start with S and there are two options. Which one you will substitute? A, B. Now here there are two non-terminals. Which one you will consider? Leftmost. So A you will substitute first. So A derives. There are many options. You will take SA. Of course, the compiler will take because you are already implemented that. Then S you will substitute first. What is S? S you need to do with the D. Then capital A. What is capital A? To get that, it should be B. So you are aware of this, right? How to derive this string. Just I am explaining the theoretical point. What is it? So here S is substituted, then A is substituted, then S leftmost always leftmost non-terminal. So here the prediction is you did with S derives AAB. The second prediction is you did A with SA. The third prediction is S with D. And fourth prediction is A with B. And last prediction is B with C. These are called as predictions. You predicted S, A, B productions properly. Yes, we can say Surya that we have a relation. We'll talk about that slowly. What is RMD in reverse? So here you can take the help of RMD. Theoretically you are doing, right? In the exam you should not use a parser. You should do directly. What is RMD? Then you do the reverse. What is RMD? First I am doing what? RMD. Okay, RMD I am taking the help. AAB. Now you will substitute capital B first. What is the capital B? You have only C. Okay, and then capital A you have. Capital you need to go with SA. Then rightmost is a capital A that you should do with the B. Then finally S with a D. So this is the RMD. But we don't want this. We want reverse. So we'll go reverse approach. How? D, B, A, C. Then S, B, A, C. This is called as what? Reverse of RMD. S, A, A, C. A, A, C. This is called as reduction process. What is this called as? Reduction process. The whole thing is, this is called as reverse of RMD. Because whatever the RMD is there, it's reverse we are doing. So RMD in reverse. So this is LMD. Now during this, you just look at that to understand. Look at this. Look at this. S you substitute with the D. This D will replace with S. But same production helped us. S derives D. This production only helped us. So here S derives D only there. But reverse process. D we found. This is called as handle. What is this called as? Handle. We replace with the LHS. So we got this one. Next, here if you look at this B, we replace with capital A. So A derives B. This B is called as what? Handle. And we replace with A. So we got that. Then if you observe this, here SA we replace with A. That means A derives SA production we took. So this is called as handle here. And when you look at up, that C is actually replaced with the B. So B derives C was the production, where C is the handle, and that we replace with the B. And finally this is replaced with S. So S derives AAB, and this is called as handle. So basically what is a handle? Handle is nothing but, okay, the RHS of this production acts as an handle, but different times different production comes into the picture. So basically RHS of the production is called as handle, and that RHS will be replaced with LHS to do the reduction. You want to perform the reduced action, that is called as reduction. Okay, so D you are replacing this is called as D is reduced to S. When you are substituting, S is substituted with D. So these are called as predictions, so substitute. These are called as reduced action, so reduction. Everyone? So this process, the bottom-up parser will do directly without knowing RMD. So this is called as bottom-up parsing approach. What is this called as? Bottom-up parsing approach. But theoretically in the exam if they ask, you can do RMD first, then just do the reverse approach, then you will easily understand what is the reverse of RMD. No need to implement bottom-up parser in the exam. Clear? Theoretically you can understand what is RMD in reverse. Top down uses LMD, and this is not there now. This is not there. That is called as reverse of RMD. Okay, that I took for understanding what is RMD. So this is called as reverse of RMD. But to do that, you should know exactly what is RMD. That's why, in the exam this would be sufficient. So they may ask many things. What is the order of predictions? Oh, that's a new question, right? What is the order of predictions? First, which one you did? S, then A, then S, then A, then B. So this is the order of predictions. S with AAB, A with SA, S with D, A with B, B with C. So this is the order of predictions. Order, LMD order you can say. And reverse of RMD, what is the order of reductions? Reduce non-terminals. So what is order here when you are going like this? What is order? First which one? You reduce to S, then you reduce to A, then you reduce to A, then you reduce to B, then you reduce to S. So this is the order SAABS. What is it? SAABS. So this is the order during the reverse of RMD. This is the order of reduced to non-terminals. So that is the reverse of RMD order. This is the LMD order. In the future, if they ask in the exam, what is the RMD order? RMD order also they may ask sometimes. Then S, B, then A, then A, then S. So you need to answer like this: S, B, A, S. So is that clear? In the exam, in case if they ask what is the order of non-terminals that you have predicted or substituted, and this one, what is the order of the non-terminals which are reduced? Reverse of RMD, RMD, RMD order, LMD order, reverse of RMD order. So everybody has order, either to substitute or to reduce, whatever. Any doubt here? Everyone is clear about what is LMD, what is reverse of RMD? Done? Okay, before learning this parser, right, we'll practice some of the possible gate questions from here. Option A, ambiguous CFG. Option B, recursive left recursion. Left recursive CFG. Option C, unambiguous CFG. So can you choose the options? Option D, right recursive CFG. Okay. How quickly you can understand? That's very important. Some of them you can choose quickly because MSQ type, right? It is MSQ type. More than one is correct here. So remaining how you quickly choose. There are shortcuts again. You can, by looking at this grammar, right, you can sometimes you can easily do choose the options. Okay, let's see who will answer it. Don't assume it is MCQ. Let me wait for your answers. I did not see the answer so far from anyone. So far, nobody was answered correctly. A, B, D, who is that? Shifu answered first time. In all the options so far, Shifu answered, I think, correctly so far. Yeah, Divyanshu. Correct, Yashwant. Yeah. So how do you do it? Are you going to practice in the exam? No. These things you should know before exam. So what is the shortcut that you will use here? Sometimes only, not all the times. When you look at the grammar, if you can observe something, do you have a left recursion? On S. And right recursion also on S, not on different non-terminal, remember that. When this observation you see in any grammar, left and right recursion with the same non-terminal, then it is going to create always ambiguous. and left and right not for a different non-terminals, it is for the same as, that's why I choose an ambiguous. If it is not for the same non-terminal, then you should be very careful, you should check it. Now I no need to check it. S is having both left and right, and S is the meaningful, not useless, it is a meaningful, so I believe it is ambiguous. Left recursion you can see, right recursion you can see. I am not asking the reason why it is not relevant, I am asking only what is this grammar. Is that clear? Everybody? So because of this, whenever you see left recursion and right recursion on the same non-terminal, on same non-terminal, then you can blindly believe same non-terminal, then you can simply say grammar is ambiguous. But if you don't have this, then we don't know, you need to check manually. Clear this point? You can note down somewhere. If you see left and right recursion on the same non-terminal, then definitely you say grammar is ambiguous. But if you don't have this, still may be ambiguous, that is different case. But when you have this, you are so lucky, you can save a lot of time. You can save a lot of time in the exam. I did nothing, just I know one point, you have a left and right recursion. Infinite strings are there, infinite. One string I am just writing it, one string. Anybody guess what string it is? BCA. Do you know how to generate? Yes, A and S with BS and S with C. This is a one pass tree. Another one, I choose this one first, now I will choose this one. BS and S with SA. Same string, right? Same string, you have two pass trees. Not this string here, infinite strings are there which are having more than one pass tree. Right, one example is sufficient. You want it, you can get it. But the problem is, when the grammar is so complicated, you can't try. You will waste a lot of time. Always in the exam, target ही होना चाहिए, कम time में answer कैसे करें, right? So कभी-कभी you will be so lucky when you have this kind of points. Okay, second. Right, options same. Option A, ambiguous CFG. Option B, you have a left recursion. What is the CFG? Option C, you have right recursive CFG. Option D, unambiguous. Okay. We'll take 2 minutes to get the right answer. That idea is very important. When you have the ambiguous option, right, focus on ambiguous. Is there any way that you can get ambiguity first? What was a string? Yeah, you got the answer right. What was a string? It gives you more than one parse tree. Now you have no technique, no shortcut. You need to understand. See, AB, you just take, there are two ways, right? AB, how do you get? One, AB, A directly can give AB, then epsilon. What is the other way? A can give A, B can give B. So look at this, two parse trees are generating the same string. In the exam, there is another kind of question. How many parse trees for the string AB? Answer should be here 2, sometimes 3, 4, 5, many. Okay? Only A. Do you have any left recursion? No. Do you have any right recursion? No. Do you have any ambiguity? Sorry, is this unambiguous grammar? No. Everybody clear? Now no left recursion, no right recursion, but still ambiguous possible. Understand? Now I don't have any left right, still ambiguity possible. But when you have it, definitely ambiguous. So understand, in the post model, if you are having left and right both recursions, you are so lucky, no need to check any string. Where is, oh, do you have any indirect recursion? Anybody? Can anybody see the indirect recursion? Do you know what is indirect recursion? In this there is no non-terminal. No, don't look at, tell me S to S, how do you call? A to A never happens, B to B never happens. Now tell me what is a recursion here? Everybody knows recursion, right? Who is saying indirect recursion? Shifu? How did you get indirect recursion here? किसी शिफू आप ही बताना पड़ेगा यार, मुझे नहीं आता. कोई कहाँ से रिकर्शन दिख रहा है? No, right? No direct, no indirect, nothing is there yaar. S never calls S, you do whatever. A never calls A, B never calls B again. Okay? Your language is finite. Recursion means it should produce infinite. This language is finite. Okay? Yeah, yeah. So let's focus on something else. X space Y semicolon. Second, int float semicolon 3. X plus Y semicolon. Fourth, int plus float semicolon. Tell me who is having syntax error here? Tell me who is having syntax error? Find syntax error. If you have any, find statement which has a syntax error. Do you have any syntax errors in this? Two and 4. Everybody, nobody is doing the mistake, right? That's perfect. Kajal, 2 also, right? This is syntax error 2. Don't assume these 2 are same. No. This is treated as like X might be keyword, like typedef might be giving that X as an integer or character, anything. So this looks like a proper syntax. So no problem with this. Semantic error might be there, but no syntax error. No syntax error. Here, now syntax analyzer, what should it understand? Right, int float, 2 keywords, semicolon, no meaning at all in the world. Right, either you should include the constants or variables to deal with these keywords. These keywords do not have individually no meaning. Right, you cannot use them individually defined but for other purpose. Okay, this is a syntax error. You cannot write this statement in the code any program in the world, any C program in the world. X plus Y, oh, this is valid, no syntax error. But you may have a semantic error if X, Y are not declared, that's fine. And last one, int plus float, plus is for what? 2 integer, plus is for 2 variables, not for the keywords. Variables or constant should be there, but these are keywords. Keywords never be added, you know, right? This will be syntax error. Correct? It's very easy, I think. You can easily answer it. Okay, I'll wait for your answers. Just find out where do you have a syntax error. Find the statements which are having syntax errors. What is it? Where do you have a syntax error? I want all of them in the single line. Okay, 5, 6, 7, 8, 9, 10. Which one is having syntax error? I think nobody answered all of them in a single line so far. Yes, that system will decide, right? Size of integer is 2, then 2 plus 4 will happen, right? If the size of integer is 4, then 4 plus 4 will happen. So that depends on the machine. The output may vary machine to machine. Yes. No, no one answered that. I'm waiting for the right person to answer all. No, no, no. No one answered that so far correctly. No. Missing at least one statement you are missing here. Manjit, when you write that statement, it will only return one value. No, it will not return two values ever. It will only return 10, 12. You can write Manjit, but it will only send it 12. It will not send it 10. No one at. I'm saying any one person can do it. Yeah, you are the programmer, you are the computer science student, and this is the you can easily write. Right. Come on, yaar. I want to see at least one a beautiful programmer in this class. Even Sunitish, I am getting also same issue, right? My network is also fine, but PW app is not opening. Yeah, please raise the complaint. There, what is issue? First answer came. Who is that? Ritik. Yeah, Ritik was right. That's I was waiting for the one person at least. So here you have an error because what is missing? Which error? Syntax error only we are talking about, right? Syntax error. Here this is missing. Expression is missing. And here also same thing, missing expression. To decide true or false, the compiler needs, right? So this is syntax error. And here also, this is not a first syntax. First syntax is 2 semicolons should be there. So this is not a first syntax at all. Whole syntax is a problem, right? So many things are missing here, syntax error, right? Semicolons are missing. And for should have a semicolon, not a comma, yaar. Semicolon should be there. So this is also syntax error. And this is right. What is the meaning of this? You did not write anything, still for loop takes the value here. What is it? It takes here true by default. And others are nothing is there, it's fine. But this takes by default true. So this assumes the true. So this is an infinite loop basically. So there is no syntax error here. No syntax error. This is actually infinite loop. I put a comma, right? This is infinite loop. And if you try to execute this program, your program will never stop. No syntax error. It's an infinite loop. And this is the function call. Here also no syntax error. Why? This exactly looks like a function call. It is not a for, right? It is a fro. So f, it looks like a function name. Function name 3 arguments. This is a function call, not a fro, not a for. Remember that. It is the function call. Fro is the name of the function. If it is not defined, semantic error. If it is defined, semantic error will not be there. Okay. 10, that 10 is a fro. Fro is a function name. So compiler knows that there is a function call. I know people may assume it is a for. If it is already for, then already here for, why do I write? Both are different statements, right? There will be small change, no? Got it, everyone? So everybody got how to check the syntax errors? Right. Everybody able to understand syntax errors? When will it happen? And some other times, like when you miss the semicolon, also sometimes happens. Correct? Yeah, they are very simple, but when there is simple, you don't look at properly. Okay. Are we ready to start with LL1 parser? That's LL1 grammar basically. Are we ready? There are many things. How to write LL1 grammar is different. How to check or how to identify is different. Is that clear? These two questions are different. How to write LL1 grammar, that is a semester level question. How to check LL1 CFG, that is a gate level question. Because here in a competitive exam, they ask how to check. Because they don't ask you to write. They will give you, you need to check. Right? Here, how to write, that means you should have the whole picture, how I should come up with the LL1 grammar. Everybody? These two questions are different, even though they have a relation. Everybody got the point? How do you write LL1 grammar? How do you check LL1 grammar? Some grammar is there, I want to know whether it is LL1 or not. This is the gate level. And you want to write, you want to invent LL1 parser. You want to create your own LL1 parser. Then you need to write LL1 grammar. Here what you do? First, what you do? Take unambiguous CFG only. You cannot take ambiguous. Okay? If you take ambiguous CFG, it will not work. Second, here eliminate left recursion. Eliminate left recursion. You get non-left recursive CFG. And do left factoring. Don't eliminate, do left factoring. So you get left factored grammar. Then now build LL1 table. Build LL1 table and check no entry has more than one production. No entry has more than one production. If any entry has more than one production, right, then that is not LL1. Then we say it is LL1. So we have found how to write. Now this CFG, that is, now we got LL1 CFG. In case if you have multiple productions in the same cell, then this is not the right way. So you need to change again concept. You need to change the productions. You need to come up with the beginning again. So finally, if you don't have multiple production, that is the grammar LL1. Everybody clear how to write it? It's a very lengthy procedure. You should know what is unambiguous grammar. You should know how to apply elimination, and you should know how to do the left factoring. Then you should know how to build a table. Then you will get to know, oh, is this LL1? Clear? It's a very big procedure. It's a very big procedure. If you want to check, everybody, if you want to check LL1 CFG, there are many approaches. Sometimes, not all the times. The first, you can try concepts like ambiguity, left recursion, common prefix. There are three things we will look at. We'll practice it. This is going to be the first concept. Look with eyes, only eyes only. Don't use a pen and paper. Try with eyes. Ambiguous, left recursion. You see any common prefix? Then the grammar is unambiguous. Grammar is what? Not LL1. So if any of this you find, it is not LL1. Everybody knows that. What is ambiguity? What is left recursive? What is common prefix? Everybody knows this. Come on, quickly here. Do you know ambiguity? Do you know left recursive? Do you know common prefix in the grammar? Right and two productions are having common prefix. Then you will come up with the answer. Any one of them you found, the answer comes very quickly, because eyes only should look at, not pen and paper. Okay, just look with the eyes. If you observe anything, then come up with the answer. It is not LL1. So you can eliminate the options at least. You can't choose it, but you can eliminate the options. Only to eliminate the options, not to choose. Remember that. To eliminate options. To eliminate CFGs which are not LL1. Which are not LL1. But you cannot choose LL1 by only checking these three. Everybody, if suppose grammar is not ambiguous, grammar is not left recursive, grammar is left factored, no guarantee it is LL1. That's why you can't choose these three for checking choosing LL1. Only you can choose to eliminate not LL1s. If you have the four options, you can eliminate not LL1s with this approach. This is the first approach you try always. Now we have the second approach. Second approach is a shortcut. That is only you do it. We'll apply shortcut. What is it? Shortcut. There is a third approach, but we never do it. That's a very lengthy approach. That is building a table and check it. We never do that. That's the actual approach. But in the exam, only in exam, how do we do? Shortcut is very simple. If you have the non-null production, if you have these productions, just check what is the first of alpha 1 and what is the first of alpha 2. If both are not having common terminal, then no issue. No issue at all. If you find not equal pi, then it is not LL1. So check these two rules would be sufficient. We'll do that later, not now. First of alpha intersection. Now we'll learn first and follow, then we'll come to this later. So in the exam, those people who have studied the compiler, and if you are doing checking only these three is not enough. Okay, these three will only help to eliminate not LL1s, and this is the actual one you can believe. But if four options, three eliminated, one left, no need to apply this, because already that is LL1. Okay, take intersection, it should be null, empty set. So if you are able to prove this for every pair in the grammar, for every non-terminal, then we say it's LL1. If you find anywhere not equal to pi, means the grammar is not L1. We will see that. So this is the actual shortcut, will help you all the time. Whether you do this or not, this is enough. But this one will help you to save your time. Unnecessarily no need to apply on every option. This one takes time. That's why with the eyes you do it, with pen and paper, and with eyes also you can do sometimes. Okay, so this is the actual problem that we face, how to check the LL1. In the exam, we are not sure how to check the LL1. We do some other techniques, we may fail. Is it clear? This slide we will do after knowing first and follow, after knowing what is left factoring, after knowing how to eliminate left recursion. Is that clear? First we will learn what are these three techniques. eliminate left recursion, how to do the left factoring, then how to construct the table, then we'll apply the shortcut. Are you ready? So this is what we are going to learn. Of course, don't ask any question now. Nothing started. So this is the overall picture of LL1 parsing concept. In the exam, this would be sufficient what is there in the slide, and whatever each word that you have written here, right? If you learn that, then LL1 parser is over. Clear? So what is the sequence of the topics that we are going to study? First topic is topics only. Elimination of left recursion. Of course, we don't solve many, just I will revise you with one example. Second, what is left factoring, how to apply it, that's all, not more than this. 3, how to find first and follow computation. Then fourth, LL1 table construction. Then fifth, how to check LL1 grammar, how to identify or how to check. Done? And it is sufficient for the LL1 parser. You don't need to go beyond this for the exam point of view. Okay, let's begin with the left recursion. It was a direct gate question. Left recursion elimination. Only one non-terminal is there, then it is so easy. But if you have more non-terminals, then it will become complicated. Then you need algorithm to apply. Particular approach is needed. For this, you can directly apply the formula, not an issue. But problem is, before applying it, ensure the left recursion elimination we are applying for simplified grammar. Then this works all the time. If you don't have the grammar simplified right, this approach may not work, because we are clearly applying this algorithm for simplified context-free grammar. Everybody clear? Simplified means don't keep unit productions unnecessarily, don't keep null productions unnecessarily, right? Don't keep useless productions. We don't care, because we don't want them at all, right? Never keep them at all. When you apply the algorithms, keep grammar simplified. Then algorithms will not have an issue. Everyone clear? We don't take the random grammar and apply this algorithm, may not work. Because I saw some people, they take null productions and they try to apply this algorithm, for them it will not work. So grammar should be simplified before applying the algorithms, so that the algorithms can consider these productions without having any issue. Final result will be proper. Okay, what is the formula when you have only one non-terminal? So this is the formula. Suppose A is a non-terminal, you have direct left recursion, something like this. Okay, for simplicity I am keeping 2 alphas, 3 betas. Of course, it can be any. For simplicity I am keeping it. So how do you eliminate? If you have only this grammar with one non-terminal, then approach is very simple. These betas are there, right? Beta 1, take a new non-terminal, beta 1 A dash, beta 2 A dash, beta 3 A dash. Why we are doing this? Because beta 1 you need to be substituted here at the end, right? Then alpha 1 need to be repeated using right recursion. So now this alpha 1, to repeat it we are taking A dash. To repeat alpha 2 we are taking A dash. Getting my point? So repeat alpha 1, alpha 2 we are taking A dash. So beta 1, beta 2, beta 3 it can come here or here, doesn't matter. But alpha 1, alpha 2 can be repeated with the help of A dash. What is A dash? This alpha 1 will be repeated with the help of right recursion. See that I am making right recursion. This A derives A alpha 1, this A dash derives alpha 1 A prime, right? Similarly alpha 2 A prime. To stop this, I may take null production just to save my time. But if you don't want null production, you can write lengthy one. Clear? But you may ask, sir, how to remember this? You may ask how to remember this. Before remembering, have you understood first what we are doing here? Are you able to understand? See this very simple one. What's happening here? If you try to think about this, right? B is derived, BA derived, BAA derived, B triple A derived. What we are doing is simply BA star. So now here the A star is happening with the left recursion. Now we want to make with the right recursion. What we are doing now, the A is B derives, we keep A dash. This is done with A dash using right recursion. This is the left recursion, this is the right recursion. That's all. Same thing we are doing like this. The same approach I did for many productions. Same approach, nothing else. This is the alpha, this is a beta, that's all. I just made a rule like A derives A alpha beta. So now I directly written that A derives beta A dash, and A dash is going to do that repetition of the alpha. That's it. You just cross check this too, you will understand what I did. For two productions, you understood the concept. It is a BA star I did with the A dash. The same concept we are doing for any number of productions. Are you able to understand? What you are doing it, but directly I am doing with the help of formula. We created a formula, but it's a concept only. But how to remember this? Just look at how to remember this. This one, just remember the betas you always put in the first place. The alphas, these are left recursive, right? These are the left recursive productions. You keep them at the last here. Here. That's a right recursion basically. This is a right recursion. So understand the sequence, you can easily remember. But you need to separate what is beta and alpha. Beta 1, beta 2, beta 3, they don't have left recursion. Okay, remember that. So those people who can remember this formula, they can save a lot of time here. पता नहीं क्या बोलूं यार. लोग पूछना चाहिए ये कॉन्सेप्ट आता क्या, लोग पूछते हैं हिंदी आता क्या, या क्या बोलूं. गेट एग्जाम में क्वेश्चन देखे यार, इसको हिंदी में पूछना नहीं आता क्या, गेट एग्जाम में नहीं पूछते कोई, राइट? फाइन. Now how to apply it? So this one we'll practice. इसको कैसे apply करना है? We'll practice it. We'll start with an example. We'll understand one by one. First one. S derives A or B. Eliminate left recursion. What is the answer? Eliminate left recursion. We are trying to eliminate, but in the exam you need to match. This is the question. Eliminate left recursion. Oh, no left recursion, then answer is same. So we don't apply. Already free. So what is the answer? S derives A or B. Same answer. Right? When you don't have a left recursion, same comes out. Okay? After elimination. After elimination of left recursion. Okay? Shortcut, short form I am writing. Okay? After elimination of left recursion, you get the same answer. You should never doubt, sir is not applied the formula, sir is not applied the algorithm. No. If it is not having, why should I apply? Second, S derives S A or B C D. Now what will be the answer? Formula only you apply directly. That is enough. Okay. Anyhow, you may take the time, so let me write it. So who is the beta? This is the beta. Who is the alpha? This is the alpha. So now answer is S derives beta, BCD, S dash. And what is S dash job? To have A repetition, A S dash. See, this one S dash only will be there. No confusion. S never comes in the RHS side, right? Explicitly. If it's already there, we'll take. That's it. Correct? So do not try to write it. It will take much time for you. Okay, let me write the answers for you. 3. So this all are can be applied with the formulas that you have learned. S, A, B, A, B, C, or what else? E, F, or G. Yeah, that's it. Now answer is S. How many betas are there? 2 betas, E, F and G. This is the beta 1. This is a beta 2. Target is on beta. Once you are able to identify the beta, beta may be there anywhere. Maybe there first or last. Identify them or move them at last at least. Then answer will be very simple. Beta 1, S dash. Beta 2, S dash. So in the exam they may take any new non-terminal, X, Y, whatever, X, X. Then S dash should repeat the A. A it should repeat, B, C it should repeat. This is alpha 1, this is alpha 2. So you will write A or B, C or epsilon. Okay. Yeah, alpha should be there after the non-terminal. After the non-terminal. Because left recursive you are able to see, the remaining portion is alpha, whatever it is. Alpha we should take, oh don't take right. If you take the right side, right, what happens? Again you will get left recursion. No, we are converting left to right. Remember, elimination of left recursion means what? Converting left to right. Left recursion we are converting into right recursion. That is the meaning. If you are again keeping left recursion, there is no use. Alpha 1 is coming left, right? If you keep again right, then what is the job? You are doing nothing, right? Again you are keeping left recursion. What is the use? There is no use of writing this algorithm. Okay. So look at why we are making this called as right recursion. Understand, A dash, A dash. This is the right recursion. Oh, we are having left recursion. We are making right recursion. That's what I am saying, right? We are converting left to right. We are converting left to right. Done? Now, so this is where the time takes. The fourth one. Let's say S derives A, what else? B, S, D, E, F. Okay. Then A derives, let's say A, B, S, A, G. That's it. Now when you have more non-terminals, right, how you apply it? Then we should use then we should use algorithm, because in the algorithm you can go from bottom to up, top to down. It depends on algorithm. Most of the textbook algorithm, they follow from top to bottom. That's fine. So first they will apply on S, then they will apply on A. So what is their approach is, when they are applying on S first step, don't do any substitutions. Just like step 1, let's say you are eliminating S. You are applying on S. S is right. Step 2, you are applying on A productions. Step 3, let's say you are applying on B productions if you have a B. And step 4, you are applying on C productions. What is the approach you will do? Here, direct formula you will apply. Direct formula, no substitution. But here, in A productions, what we do, we don't apply formula. What we do? First, we substitute S. We substitute whom? S. Why? Because S is already free from left recursion. Substitute S if it appears at first position only. Second position, if it appears like this, don't apply. If S comes in the first position, then only will apply here like this. Here S is there, first we substitute S, then you apply the formula, right? Second, you do next, you will apply the formula. Second, apply formula. Apply that formula. But in step B, what you do? Substitute A as well as S, but recursively till you don't see them in the first position. Then apply formula. Here substitute A, S, B, all of the three recursively. How long? Till you don't see the first place, right? This 3. Then apply the formula. Are you clear? Are you able to understand what I am saying? Of course you need to apply. That means except step 1, remaining all the steps, you need to look at above what is happened. At step 2, you should look at step 1. Oh, S was free, I will take substitution, then I will apply the formula. Step 3, look up. Oh, A and S free from left recursion. Substitute here, then apply the formula. And step 4, look up. B, A, C, B, A, S. If they are coming in the first position, first means this position. This position only you will look at. Here only you look at. If it is happening in the first position, then substitute. As long as they don't come, because sometimes you substitute C, you substitute B, A might come. You substitute A, S might come. So this many things will happen here. So recursively you do it. So if you don't see them, then apply the formula. Clear? Are you able to understand the approach? Approach is very important. Then very, very easy. Let's look at now. Step 1. Always you look at where? First position only. Always your target is here only. That's why we don't keep epsilon productions, we don't keep useless productions, because I don't want to waste my time on checking this. Okay. No. All right. So step 1. In the exam, you don't see this much bigger. You just see very few. So you can do very quickly. I'll just apply this, learn it how to apply. In the exam, you can do without pen and paper also. Step 1, choose S productions. I did it. Now, is there any direct left recursion here? No direct left recursion. So don't apply the formula. I'm trying to apply the formula, but there is no S here. There is no S here. So answer is same, no change. Everybody got clear? We are not substituting because, we don't apply the formula because already free. That's assumption. Clear? Yes, Punit. Yesterday replied, right? You get the best rank. You get the best rank, then you have the. Yeah. Yesterday I told you. Again, you came back to ask the same question, right? You said yes, thank you, and then you are asking again today. Fine. This is the final answer. Now, step 2, what do you do? Here you may take time. In step 2, we don't apply the formula directly. Step 1, apply the formula directly. Don't substitute. Apply formula, that's it. You know what is the formula. Step 2, take the productions, A productions. But now, don't apply the formula directly. What do? You look at first, do you have any S here? Yes, here is there. Here we need to substitute. Why? Because S is already, we got the free from left recursion. So take this and substitute there. So now we are doing that. Substitute S. What is the answer you get? A derives AB, and S when you do with AA, AAA, because A already there, and BSD put there, BSDA, and EF put there, EFA. So what is the answer? Now look at again, because sometimes in the step 2 no issue because only one time, but in step 3 multiple times might happen. You just check again, A, B, E. Oh, no S, then you are lucky. No S, you are lucky. So now direct formula. I can see no S, so no substitution. Now apply the formula directly. Why? Because you can see capital A. But if you can't see capital A anywhere, then formula is also not needed. Apply formula to eliminate left recursion. What is the formula? What is the formula? This is alpha 1, this is alpha 2, and this is the beta 1, and this is the beta 2. So what is the final answer? Beta 1, B, S, T, A dash. If A dash already there, take A double dash. If already there, take some non-terminal Y. Okay? E, F, A dash. And what is A dash? Do the right recursion, what you see? B, A dash. A dash. That's it. Epsilon to terminate. This is a 2. What is the final answer? In the exam, what is the final answer here? 1 and 2. You write in a sequence. This is the final answer. Done? This time, how much time you spent, right, for explanation. But even you want to apply, it will take much time. So in the exam, you don't see this much lengthy grammar. Only 2 or 3 productions, 4 productions, you can do it very quickly. Okay, you can easily identify quickly. You can see one example. Oh, G will not come. Where is the G that I took? G should come, right? Did I miss it? I forgot. It should come. I forgot copy paste. Sometimes happens. I did after substitution, I forgot to take it. Okay, so you should do it. So this comes as B3, right, beta 3, and I missed it. G A dash. Sorry for that. That's the problem, when you have so many productions, you might miss even single thing, you will get the wrong answer. G should come, no doubt. Only I did the substitution here, I forgot to take as it is. Okay. Yes, that you can understand what mistake I did it. That's a copy paste mistake. So everyone understood? Let's move to the few points in which case it will help us. Look at this. In the exam, what kind of questions they may ask? This is a one possible question. Very famous question. So how do you eliminate very quickly? Direct formula, right? Direct formula. How do you do it? E derives. Who is alpha, beta? That you need to find. So this is the alpha 1, this is the alpha 2, and this is the beta. So take Ax. No need to take E dash, take X. X does. This is a plus E X, right? Or star E. what is it, x or epsilon. Are you able to understand how to eliminate? This is the free from left recursion. After elimination of left recursion. So this kind of questions predictable in the exam, that by looking at it only you will understand, right? अभी तक कोई दिक्कत है? ऋषिकेश, hi. The another possible gate question is, okay, but here just remember, here unit productions are there, that would be fine, but only epsilons will create an issue. So this unit productions may be allowed, that's not an issue, okay, right? In the simplified I told, right, but this is not a simplified. So unit productions will not create a problem to this algorithm. Null productions can create an algorithm, create a problem. So I'm just keeping it. If you don't want it, you can also do one thing. You can just write ID. That's fine. Okay, that would be fine. So this is another way to write the same grammar. Okay, I'm just writing. Oh, let me change the grammar a little bit because I changed it completely. So this is fine. Okay. Now can you do it quickly? I changed a little bit grammar. So you have a left recursion. Do you have a left recursion? See now, T never depends on E. E depends on T, but T depends on T and F not depends on anyone. So it's very easy. First apply on E. Step 1. I'm directly applying on E. So how do you do? ID E dash. And what is E dash? That plus T should be done. So for E I written. Now go for T, step 2. Now you can't substitute the E because E is not there. You can see that E is not there. So don't substitute E because not there. So now apply directly. What happens if you apply directly? ID T dash. And what is T dash? Star F. See, I don't need to write step 1, step 2, all this. You can do it very quickly. Done. And F has no recursion. So that's all. This is another possible. One gate question was there similar to this. Here there were no substitutions because T is not having E at all. So you are so lucky substitution will not happen. F is not having T and E. You are so lucky substitutions will not happen. So directly you are applying the formulas because substitutions will never happen. Are you clear? This is the answer. In the exam, what kind of questions will come? That is, can be answered without using pen and paper. Do you see? Pen and paper not required. Question is there, option is there. Just need to cross check. Fine. Left factoring. Left factoring nothing but identify common prefix and eliminate it. So how do you do basically? If you want to apply the left factoring, the grammar should be unambiguous and grammar should not have left recursion. If you have left recursion, eliminate. You have already grammar, right? Okay, so let me complete very quickly. It's only revision, right? You know all these points, right? So everything I no need to take. Just take important points, then close it. That is also fine then. Okay. For example, A, B, A, C, D. So do you have a left recursion here? No, you should not. If you have, eliminate it. So now which is the common here? A is the common, here A is the common. If you don't have it, just keep as it is. Suppose here B is there. The B is not having common, right? So only which one is the common? A is only common, right? So remaining you can do as it is. So how do you eliminate the common prefix? S derives A, just write X, and B is not having an issue, and X you have either B or CD. Now do you see any common prefixes? This is called as common prefix, right? This is called as what? Common prefix. One length only you look at, because LL1, for LL1 is an issue which production need to be chosen, that's why we are eliminating it. Common prefix of one length only you look at always, right? Again, after doing this, just check, sometimes this might be B, so look at if there is no common thing and finally choose it. So here observe later on, A is here, B is here, okay, no problem. Here B is there, C is there, no problem. So this is a left factored grammar. What is it? Left factored grammar. And what is this grammar? This grammar is non-left factored. What happened in between? We applied left factoring algorithm. Clear? We eliminated the common. This kind of concept you apply for any grammar, but you need to introduce new non-terminals to do it. Just to ensure that you don't have a common prefixes, you apply this concept. Okay, no need to practice here, I'll just ignore. We'll go for directly first and follow computation. So first and follow. So I don't write all the principles directly, we'll go for the practice. Revision only, right? So let's take the first example. S derives A or BC. Tell me what is the first set? What is the meaning of first of S? What do you get here? You get A comma B. Why? Why do you get first of S is A comma B? The reason is S may derive any string, but that is either will start with A or it will start with B. Yes or no? Everybody, if you are computing first of S, whatever S derives, I don't care. Only I care what is the first terminal. It must begin with A or it must begin with B. But it's so easy because you are able to see it directly. But is it always possible directly? No, right? A non-terminal might be there. That non-terminal might derive some other terminals. It may take time. So this grammar is so simple, that's why you are able to compute very quickly. But is this always easy? Follow will do it later. Follow don't touch now, okay? Because first, after that first we'll compute follow, then we'll come to follow. Sorry, after first we'll go to follow later. Now look at the second example. If I have a non-terminal something like this, you need to work on a little bit to understand what will come here. Now it's not easy, right? It's not easy. B will understand, but what is here? The A will decide what is here. A will decide. Suppose if I have E or F, G, something like that, then it takes time again. Here you need to compute what? Two things. First of A is so easy. So let me compute first of A first. First of A is what? E and F. So easy, I'm doing it. But first of A's is not that easy. Why it's not that easy? Because it depends on this production. So now here, how do you compute? So this E might come here, and out of this two, this F might come here. So here you will see either E or F only, right? This A will never come. So E, F may come as a first position. Here B is there. So E, F, B. So what do you answer? E, F, B. Of course, this should not make much difficult. And remember, when the grammar is not having epsilon, you are so lucky, because we can do without pen and paper. Only when you have epsilon, then it takes some time to gather all possibilities. Correct? Third one, let's see. S derives S, A or S, B or epsilon. Epsilon. Can you compute first of S? So this is the key I'm talking about. Here epsilon is there. This makes there are some indirectly that you can't see here that you need to identify. You might be assuming, oh, it's epsilon beginning. No, epsilon is not a terminal. Directly epsilon is there, it's fine, you can take it. But remaining, you can't believe that. Epsilon A means A, epsilon B means B. That means the string might be epsilon, or string might start with A, or string might start with B. Everyone? So here you will see somehow either A or B. So answer is here A or B. Why they are coming? Because of here S, you can substitute epsilon, then epsilon A you will get as A as the first. Correct? So when you get epsilon, you just take time to calculate. Don't assume it is so easy. Just need to substitute and get the answer. Fourth. When you have other non-terminal, so look at similarly. You have a B or epsilon. How do you compute now? First of A is easy, so do it quickly. Epsilon comma B. And first of S, what is it? Don't say first of A, that is wrong. A may not give you, it may give you B, but it will epsilon, when you put epsilon will not come. Because of epsilon, A will come out. Are you getting my point? Because of epsilon, you put there, then A comes out. So here B comma A is the answer. Epsilon will not come. Epsilon will not come. Correct? Oh, B, epsilon will not come. Epsilon will, why epsilon will not come? Put there, you will understand. From S, can you derive epsilon? Impossible, right? Either you will start with B or A will come, that's it. Epsilon, never, you can see that. Epsilon impossible there because always A is there. Okay? When A derives epsilon, don't assume S derives epsilon, wrong. Here epsilon comes only when S can derive epsilon, but this situation will happen. When S derives A derives epsilon, oh, then you can believe because no other option, no other option. This time S will derive epsilon. But here small a is there. So S, don't assume epsilon will derive, no. Okay? Let's introduce the follow, then come to this first together. Together I want to compute. Okay, follow set. Suppose S derives A. What is the follow of A? So what is the follow of S? Quick. Second. Suppose S derives SA or B, then what is the follow of S? Suppose you have S derives SA or SB or ES or D. What is the follow of S? Okay, just take time. If you know it, please answer it. Otherwise, I'll just take time, few seconds. By default, the start symbol will have the dollar as the follower by default. I'm just looking at the third. 1, 2 are correct almost, that you are doing good. As you understood. even without a definition of the follow set. Yeah, good. You are able to understand third one perfectly right. So what do you mean by follow of S? So when you are deriving string, right? So there is called a sentential form. Sentential form. What is the sentential form? Anything you derive from start symbol. Like you start with S, you derive any sequence here. You derive any sequence. Right? In this sequence, if you see somewhere S. Now we are asking about S only, right? Ask about capital A, anybody. So after S, who is going to be the terminal that you can see? So we are finding this. If you don't have anyone, we assume dollar. If you have anyone, you should find out. So that should be terminal we want, not a non-terminal. Okay. So now look at here. If you start with S, right, you get A only. You get no S. That means after S, who is having dollar? We assume. So here by default, this is the principle. Dollar is considered as the end of the token sequence. So how do the parser know the end of the token sequence happens? It will assume dollar is there at the end. Okay. So while parsing, while verifying the syntax, it assumes that the dollar is the end of the program. So that is how the follow of S, it assumes dollar. So anything that I derive that everything matches, then dollar should be there. So now don't worry about the dollar right now, except the theoretical point. Practically there is a much importance. Now here dollar by definition, because S is the start. Now after S, who is there? You can see it. If you can't see it, find out. Okay. Now after S A, after S B, after S no one. So this is very important. How do you compute for that? So let me write. So here you are able to see. Here you are able to see. So dollar A comma B. So how do you compute here? So this definition is after S nobody there. So you just come LHS, just find who is after S. So this means compute the follow of S. Anyhow we are computing the follow of S, no need to go further. But if this is a different non-terminal, then follow of S, this is let's say X, then follow of X you have to compute. So third I am just writing a different way. Just look at the fourth one. S derives, suppose I write A capital A, B capital B, then capital A capital B, you will understand how to compute. Okay. Okay. D. So now look at follow of S is so easy. Follow of S is so easy, dollar only, because S is not there in the RHS. Look at whole grammar you have to look at. Follow of A, look at whole grammar. So here A is there. So it's very easy, you can compute A, but here A is there. Oh, this A means follow of A means follow of S. Follow of S already computed, just copy paste. So this is the important. After A, when you don't have anyone, then come to the LHS, compute its follower, then copy paste. So I did that. This dollar because of this A, and this A because of this A, capital A. Now follow of capital B, look at all entire grammar. Only here is there. Only here is there. Only here. So who is there after B? No one. So you compute from here only. So you get just dollar. Follow of B means follow of S. Are we ready to practice follow and first? Then we'll go to LL1 directly. Okay. Can you compute? compute first of E and fall of E now. We are computing both of them, right? What is the first of E? From here we'll compute both. First of E and fall of E. Once you do this, just go for the second question. We compute the gate pattern questions they are. Fall of E is correct and first of E correct, Sakshi. Yeah, correct. Get anybody doing wrong? No, right? Yeah, very easy. So this is the most important question for the compiler. Done? So then we can go for LL1 table construction. If you are able to do it, you're almost done. This is A, fall of is plus is there and star is there, and fall of is fall of E, fall of E is fall of E, no need to worry about it. So okay, just write dollar because star symbol. First of S, oh this is anybody computed? First of S, so A you can see, open parenthesis you can see, and is there any chance that here right parenthesis directly comes? Never, right? So either A comes or open parenthesis comes, because in the beginning you will never see, like this, right? But follow of S, you need to find out all possibilities. By definition dollar, and here after S you see close parenthesis, and after S you can see here even open parenthesis, because after S this S you can put with A or you can put with this one. So you can get the close parenthesis or open parenthesis or A. Very important, the follow of S in this one, because here you see after this S, right, after this S you can get this one, after this S A also possible. Why? Because this S I can put with this one or this one, so then you will see this kind. So very important, the last one. If anybody is missing computing A, because you are putting this one but you are not putting this one, okay? A is missing, right, Ritik? Why A is missing? A should not miss, right? Correct? See, some people are not able to compute that follow of S. Open parenthesis also comes. Everybody, anybody miss the follow of S? This is one of the important question, because of that two non-terminals are coming in a sequence, then you are in trouble, right? These two non-terminals are very carefully you should look at. Yeah, I know. That's why I took these examples. At these examples, the last one, this example you should look at carefully. Okay, let me take that is separately. Some people are still facing an issue. See here, S derives S. Have you understood the definition of follow of S first? Then let's look at that. Follow of S means, where do you look at? Where do you look at? You need to look at three times, not two times. You need to look at this S, you need to look at this S, you need to look at this S. So when you look at this S, okay, by definition dollar. When you look at this S, you will get right, closed parenthesis. When you look at this S, follow of S means what? First of this one. What is S? S can give you this one. You can see that. If you are asking first of S, what you can get here? You can get here this one, or you can get SS, you can get A. See that, you are able to get that, right? Open parenthesis and A. And follow of S means follow of S, no need to compute, that's already we are doing. This is the problem that you are facing. Everybody? How you look at the follow of S. Every S in the grammar is important. Whole grammar, not only S productions, even you have capital A productions, there also you have to look at S. So whole grammar you have to look at, and every S is important. If you miss one S in the grammar, then you lost the answer, right? This is how you compute the follow of S. First of S might be easy because your target is on S. Because S productions you take, you may find the S. But follow of S, whole grammar you have to look at. Now, another important gate, LL1 table construction. Then after that we'll check LL1 grammar. Can you compute the first and follow? What is step 1? Step 1, compute first and follow. But you can use the shortcuts again. You don't need to compute for everybody. Then step 2, you should construct LL1 table with the help of first and follow. Step 3, just cross check, check table if any issues. If any issues. Yeah. So you can do that, right? First and follow. What is the first? First of S. Epsilon. Oh, now A, you are, see, small a, or AB when you put, you never get a B. So A only comes there. So epsilon comma A. First of capital A is just A only. First follow of, now which one requires a follow? Out of them, only for this one requires a follow. You don't need other one. Follow of S is just dollar. Now the question is, only the first set which contain epsilon we need follow. We need follow for S. If you see epsilon here, first of S is epsilon, then compute the follow of S. If you see first of A also has epsilon, then compute follow of A. So if you don't have epsilon in the first set, don't compute the follow. Okay? If you don't have epsilon in the first set, don't compute the follow. Why? If you are getting something when you are looking, then don't look at who is after. Is it clear? This year you are able to crack the gate, then don't look at next year what to do, because you know what to do next year by definition. So this is very important. If you are not getting the gate rank this year, then next year you have to look at, means after. The same way, if the first of S you are getting epsilon, then follow of S you have to look at, otherwise no. So after this, now how to construct the table. Table is 2 rows you have. How many rows you have? 2 rows. Why 2 rows? Because 2 non-terminals. Because 2 non-terminals. How many columns are there? Small a, small b, and dollar. And dollar. you can see that S, A and small b dollar. So this is LL1 table. But now you look at the combinations. Where do you look at combinations? See here, S with A, epsilon don't look at, A with A. Now SA, here you need to find which production of S. Here, which production of S gives A as a first terminal. Which production of S, which rule of S gives A as a first terminal. So S has so many productions. Which one is giving? This or this. Epsilon will not give you A, right? Only this one. So here you will fill A. Everybody got this point? Here you will get A. Or you can write whole production, not required. See, S derives A, no need to write because these are S productions only. These are S productions only. Okay. Now one is over. This one is over. A comma A. So there are two productions. Which one gives that A? This one also gives. This one also gives. Here also A can come. So two productions are going to come, AB as well as A. There are two productions are going to come here. So in this cell you have multiple productions. Stop. Say that this grammar is not LL1. How do you know that? Because you should never get two productions more than one in the same cell. 0 is fine, 1 is fine, but more than 1 it should never come. Stop here, don't do any activity. Say that please modify the grammar, then build the table, because you're not building the LL1 table, because this is not believed as LL1 table, because you have a problem, you have issues, right? So now you can say that, oh, given grammar is not LL1, multiple productions are there in the same cell, right? Not LL1. But anyhow, this is a lengthy approach. We are only building the table, right? Next one. Because of this null production, now we need to look at S comma dollar. S comma dollar, out of this, who is the null production? This one only, right? So you write epsilon here. Null production you are going to write, null production. The null production might be epsilon, might be something else. Sometimes null production might be different. Here epsilon is there, so you are so lucky. Sometimes B might be there, B derives epsilon. Then you should write B only there, not epsilon, okay? So you should be very careful who is giving epsilon. Okay, whoever gives epsilon out of these two, then put that. S productions only you have to write, A productions only you have to write. Now, by looking at this, the grammar is, you can conclude, oh, multiple productions in the same cell, more than one production here. So, given CFG is not LL1. This is a very, very lengthy approach. Should never do in the exam. But if the give table, then directly you should see, oh, this cell has two productions, then we say given grammar is not LL1. In the exam is another type. They will give you table, just you need to say LL1 or not. Okay. Anybody tell me what might be the reason? What might be the reason it is not LL1? Do you see the left recursion? Do you see the left recursion? Do you see the left recursion? This is the one reason why it is not LL1. This is the one reason why it is not LL1. Of course, you might have other reasons. One reason I am telling you, here you have a left recursion, that's why A comma A, multiple things are coming here. They might ask you in the exam, what is the reason? Is it ambiguous or left recursion? It is a left recursion. Due to left recursion, this grammar is not LL1. Okay, second one. Tell me, what is the table construction? Can you do it very quickly? See how I do it now. I don't need to do anything. Just in the exam, right? Just do like this: S, A, R, B, or dollar. Now, first of S, just keep in mind small a comma small b. So S comma A, ASA, S comma B, B. That's it. You don't get anything. No null production. No null production. So no follow computation. That's all. Directly you do it. Very quick. It's very quick. If I do the another one, you see, observe what I do next. AS, B, or epsilon. See how I'm going to do directly without using first and follow. But you have to do in brain. Okay. Just do logically without using pen and paper. Now look at first of S, A comma epsilon. First take care of A, S A. So you will get ASB production. Now because of this epsilon, you compute follow set. Follow of S, B and dollar. So dollar and B, you are going to write null production. That's it. Are you able to understand? These are LL1, that's why you don't get multiple productions. These two are LL1s. But checking LL1, we don't have this approach. We don't do this in the exam. We have other shortcut. What we do in the exam to check LL1? What is the first? First of ASA intersection. What is the first of this one? B. So this is A and this is B. So no common terminal. So we have no issue. Here also same. This is the first is. Here we have epsilon, so we compute the follow of this one. So follow of S, here you, what is it? ASB, right? So this is A intersection, follow of S, you compute from here, B and dollar. So again we have no issue. That's why pi. That's why pi. So we are using the shortcut now. When you see epsilon, compute the follow of LHS. When you see other than epsilon, compute the first. But every two productions you need to do for the S. S has many productions, then every two productions you need to apply this kind of logic. Only two rules. When you don't have a null production, this rule. When you have a null production, in place of epsilon, just take follow of LHS. Clear? Only two rules we have. Two shortcuts, that's it. Fourth one. Now we changed. Rather than constructing the table, we check LL1. Is that clear? Last concept. Now tell me quickly, is it LL1 or not? From here onwards, I am asking the questions directly. How do you check the grammar? Now you need to use the approach. I have given the approach already in the beginning. क्या अप्रोच है उसके लिए? First use eyes rather than using pen and paper. So this is the gate again pattern. So you do intersection. Here you get A and here you get follow of S dollar comma A. So intersection is not empty. It means it is not LL1. Is that clear? If you build a table, you will understand S on A, you will have two productions, ASA epsilon. This is an issue. This is an issue. You will have multiple productions. If you want a reason, S comma A will see two things. And here you need to look at these two pairs. You need to look at these two pairs. You need to look at these two pairs. But time consuming, yeah. It is already ambiguous. Why are you doing all these things? You know, right concept? It is ambiguous. CFG. So it is not LL1. Ambiguous grammar never be LL1. That's the one more point you should begin to note. when you see the grammar is ambiguous, right? How do you write LL1 grammar? First you take unambiguous only. If you take ambiguous, impossible to write LL1 grammar. Clear? This is not L1 because ambiguous. Ambiguous. Okay? Manjit, what is it? Left recursion and common prefix. Left recursion. It is not LL1 even though it is left factored, even though it is not left recursive, even though it is unambiguous. This grammar is very, very important grammar. The fourth one, those people who are looking for, see, do you have any ambiguity? No. Do you have any left recursion? No. Do you have any common prefix of one length? No. Still it is not LL1. Are you getting my point? It is one of the important point. Even though all the 3 points satisfied, still it is not LL1. Right? Very, very important. LL1 grammar, never be ambiguous, never be left recursive, right? And never be non-left factored. But when all the 3 satisfied, still grammar need not be LL1. Very, very important. Okay? After this we'll take a break. We'll complete LL1, then we'll take a break. Who is that? Prabhakar. Yeah, even I want a break, right? So after this we'll take a break. But this is one of the important. See, this grammar, I'm writing that note also. This grammar is unambiguous, even not left recursive, not having left recursion, and grammar is already left factored, but still it is not LL1 because you have the null productions. When you have the null productions, this 3 is not enough. When the grammar is not having null productions, right, then this 3 enough. This 3 enough. This 3 enough or not depends on what type of grammar you are dealing. If the grammar is not having null productions, you verify this 3 is sufficient. But that is a theory, right? No shortcut to verify those 3. Okay, ambiguous, so not L1. Ambiguous, left recursion is there and also right recursion is there. So it is ambiguous, so not LL1. Clear? So now, rather than practicing many questions, let me write one slide, all the concepts. Let's say CFG is there. Okay, all the concepts I'm writing in one slide. CFG is there. Okay. This CFG, let's say, it could be ambiguous or unambiguous. Yes or no? It could be ambiguous or unambiguous. If it is ambiguous CFG, it could be many things again. It might be left recursive. When it is ambiguous, right, no need to look at anything. No need to look at anything. No need to look at anything. Just directly you say it is not LL1. But no need to look at anything. But when it is unambiguous, we have issues. Left recursion, no left recursion. If you have a left recursion, then directly you say it is not LL1. If you have a no left recursion, still we have a problem. Grammar may be left factored or non-left factored. If it is not left factored, or it is left factored. Then if it is not left factored, say directly not LL1. If it is left factored, still we don't know what will happen. Still we have the 2 issues. It may be LL1, it may be not LL1. That depends on if no null productions, not L1. If null productions, then you should be very careful. So you can just check here the last step. If no null productions, no null rules, then you can conclude LL1. If we have null rules, then check table. Then check table or formula, check table, then decide. Don't decide blindly. If you have a null rules, then grammar may be not LL1 sometimes. So this is the entire concept that you need to understand. Grammar is ambiguous, check blindly, say that it is not L1, don't go, right? Don't check anything. If it is unambiguous, still but a left recursive, right? So understand these points. Okay, CFG, there are other theoretical points are there. Directly, left recursion and unambiguous have no relation at all. But I just checked ambiguity first because ambiguity makes a more confused. So I started with ambiguity rather than left recursion. Okay, you can start with the left recursion also. If it is left recursion, not LL1. If it is not having left recursion, maybe you need to check ambiguity. So there is a lengthy approach again. So keep this in mind to check the grammar is LL1 or not. But don't do anything in the exam. Just put, is there any left and right both? Or do you have any left recursion? Do you have any common prefix? Then you can conclude directly. If ICE cannot answer it, then use the shortcut, but don't use this approach at all. Okay, it is just the idea how we got conclusion to LL1. Okay, everybody clear this point? Don't apply whole approach step by step in the exam, no. But this theory will help you in the exam. They might be using this kind of techniques. CFG is unambiguous, no left recursion, still left factored, but can you conclude LL1? You should say no. But no null rules? Yes, LL1. If you have a null rules, may or may not. Okay, so look at this example. Previous example only we have the answer. This one is not LL1. If I have a B here, this is a key. If you have a B here, this will become LL1, right? So very tricky. Previous question only I have written that. This is, see that you have a null rule. This is LL1. This is LL1. But same one here, follow up as I kept A, then I got a problem that is not LL1. Okay. So I hope with this we have completed LL1. So we'll take a break. After the break, we'll complete LR parsers. LR parsers more theoretically will go rather than looking at each and every point. Okay. How to compute closure go to, how to check the all different parsers, all different grammars in a one shot. Done? What we have learned so far, it is much important in the exam. So many gate questions are there in the first and follow, ambiguity, LL1 checking and table. Okay. What time we'll meet back? 12, right? 12. What time we'll meet? 15 minutes break. What time you need, guys? 5, 12, 5, 12, 6, 12, 10. Anybody want to take much break? 12:30? Is that fine? Or 12:20? 12:25? Oh, 10 minutes enough? I just do something here. Okay, I'll come back. Okay, this is the agenda for bottom parsing. Okay. The most important one is here, this one. Most important one. Then next important, this two, that's it. They don't ask whether you consider diagram or table, that doesn't matter, right? So you should know the relations, and the given grammar is LR0 or not, that can be done without construction also, by using some shortcuts, like if the grammar is ambiguous, no need to do anything. Okay, are we ready to go for come on, are you back from the break? I'm seeing the chart. I can see. Is the chart delay or we are delay? Perfect. Okay, let's begin with the closure and go to functions. That is with the help of LR0 construction. So first we will focus on LR0 state diagram. There we will understand closure and go to. So LR0 construction. I will help you the differences only once you learn all the individual passes. Right. Suppose I give you grammar. I'm giving you grammar, right? So what we call here, if I give you any grammar, first what we do, this is, let's say some grammar is given, A or A to B, something like this. This is your grammar, right? It is CFG. We always convert into augmented CFG. Which CFG? Augmented. We append one production to understand the bottom of parsing. This is S dash derives S. If you do not have that, accepting is going to be difficult. So this production will help us how you need to accept. That means how do you know that the syntax is verified? To understand that, this is called as acceptance production actually. It will help us to understand how to accept the given input. Then with this we will construct the table as a diagram. Construct diagram, or you can maintain the list. There is another way, either construct the diagram or maintain a list. You can create list. Every state is just a list only. That list will put a box. So create a list or construct the diagram. So once you do this, then you may construct the table. Of course we don't do that as it takes much time. Construct the table. Once you construct the table, then you will know if the table is not having more than one entry in the same cell, then multiple entries are not there, then the grammar is LR0. But we don't go there to check, we can check here itself. Okay, in the exam, either you can check here or you can check here itself. Sometimes the grammar is ambiguous, no need to do anything else. So you don't come here. You don't come here, you will stop either here or you will stop there only. So this is going to take time consuming, so we don't do this in the exam. Okay, construct the table. That means if the table is valid, then we are ready to implement, or we are ready to start LR0 parsing. So if you want to implement LR0 parser, these are the steps you need to do. It's not only LR0, SLR1, CLR1, LLR1, same approach till the table. Everybody? Come on. Are you able to understand how you need to build a table for the parser? So conflicts you can check in both of them. You can check here, no need to construct the table. You can stop here all the time. So we take always augmented CFG. If this is given directly, start constructing. If this is given, this production is not there, then add it and do it. Okay, I'm going to start a construction. Okay. Here, while constructing, we always take the items, not the productions. What is item and what is the production? The item we call here, every production we call item, because we are going to place. We will place a dot. We'll place a dot inside production. For what purpose? Anybody knows? किसी को पता है? Why we place a dot inside the production? Anybody having an idea? To track how much production we have understood, or we have remembered on the stack, or we have analyzed it, or we have tracked it. So dot is very important to understand what we are tracking, right? So you are reading it, right? Suppose you have something like AB. Then to reach something like, let's say, that's A, capital A is there. So now what's happening? If the dot goes here, then only this B can reduce to A, otherwise you can't, right? If the dot goes there only, the B will reduce to A. If the dot is here, if the dot is here, if the dot is not here, if it is here, then still you can't reduce. Only the dot will help us how to reduce to the starting symbol at the end. Okay? So we'll place a dot to understand how to derive a string with the help of this parser. Okay? So what is the item here? The item, if you take, let's say S derives A. This is a production, right? What is this? Production. But in this construction, here you may come up with dot AA, or you may come up with A dot A, or you may come up with what? AA dot. Can you see that? When you are doing this, see after dot who is there? Terminal is there. Then this is called as shift item. Which item it is? Because it can be used for performing shift action basically. After that, when there is a non-terminal, we call it as a state item, which will help us internal tracker. Okay, internally we use that. And dot is at the end. Oh, that means it is a reduced item or completed item. These two are incompleted because dot is there other than at the end. This is called as completed. This is called as completed. So are you able to understand what is item? Item means dot is there somewhere in the production. Dot is there somewhere in the production. And there are three types of items. Shift means after dot, not before. Before maybe there, may not be there, doesn't matter. After dot terminal is there, immediate symbol. After dot non-terminal is there immediately. After dot no one is there. So if you have a terminal, shift item. If you have non-terminal, that is used for internal purpose, called as state purpose, will help us to make the go to entries. This will help us to make the shift entries. This will help us to make this reduced entries. Basically shift item will give us shift actions. State item will give us go to entries, and reduced item will give us reduced entries. Everybody? So every item has a particular purpose. So when you construct the table, you will understand what these items are. Right now, I'm just explaining theoretically. We have items. These three types of items we are going to face while you construct. Okay. Right? what is item? Because we have only items here. Now let's construct the table. So I'm going to construct the table. We always begin with this item, and this item is solely responsible to construct the whole, right, whole diagram. What is the production? Let me write production here, because later on we may get the help. What is it? AA, right? AA, and then A derives B. Now you see, because of this S, we are writing S productions, otherwise we don't write. So we write S production, and we always place the dot, and that is A, capital A. And who is here? Terminal. So now every non-terminal that you see, we are applying the closure. So initial, this is called as I naught, but I naught we have a name. I naught is actually called as closure on S dash derives dot S, which is given the list S dash derives dot S. When you apply on this, we got another item, that is S derives dot AA. So what is the closure? When you are applying the closure on this, and every non-terminal you are going to add the new items by putting the dot. If you have any non-terminal here, right, suppose you have like this dot capital A B, then capital A productions we are going to add here. Capital A productions we are going to add. Suppose here dot X is there, then X productions we are going to add. If you have Y here, Y productions we are going to add. As long as all the non-terminals are covered, we keep on adding. But if you have Z here, we don't add Z productions. Is that clear? We've only add the non-terminal items if they are in the first place. Okay, just after the dot. Just after the dot, first place. After dot, the first position. Okay, fine. You know, right, the meaning of this. Now we'll read S here. We got S dash derives S dot. That's it. Only one production will go there, because dot after dot S is there. Read A, then S derives A dot A. Now because of this A, right, you need to add A productions here. How many are there? Only one. And this is a terminal, so we don't add anything else. Now what's happened? So this has a name. What is it? This is called as I1. But what is I1? What is I1? I1 is actually nothing but go to of I naught comma S. Remember that what I have written. From this I naught, when I read S, I'll go to here. That is a function. The closure, this is a go to. Go to is actually calling the closure recursively. So you get this item, that is S dash derives S dot, and you apply the closure on this. Oh, it's completed, that's why you don't get anything. But when you look at this, let's say this is I2. I2 is the go to of I naught comma small a. But the first one, this is only moving here, just moving, just placing the dot after small a, because you are reading small a. That is S derives A dot A. Now apply the closure here. When you apply the closure here, because of this A, the A items are going to come. A derives dot B. And apply the closure here. It's a terminal, that's why we are closing it. This closure is applied on every item. But this state is generated from here by applying the go to function. Okay, so far happened. And here you don't have anything after dot, so no expansion. And here A is there, here B is there. And when you read A, just one thing happens, A dot. And this is also go to from I2 comma A. This is go to I2 comma B. This is a go to function. So A derives B dot. Apply the closure, you get the nothing. That's only the last, right? Apply the closure, you get the same thing, and you don't get anything else. So this is called as closure and go to functions. But in the exam, they can ask anything. Compute the go to of I naught comma A. I naught they will give you I naught comma A. Then you should get this. They may ask how many items? 2. If they give you I2, they have given this. How many items are there? I2 comma go to of I2 comma A. You will have only 1. So these kind of questions are happening in the exam. Okay, they are very easy questions, I guess. Once you know this, why we are computing or how we are computing that closure and go to is very easy. If they are asking only for this one, they will ask closure. Okay, total how many? I3, I4, that's all. I3, I4. Total how many states? We got 5 states. This diagram is also called as LR0 DFA. It's also called as LR0 parsing DFA. Why it's called as DFA? Because one symbol we take only one transition, we don't take multiple transitions. One symbol we never take 2 transitions. That's why this is called as deterministic machine. Any doubt here? Please let me know so that I can help you to compute. You're not able to understand any state, let me know. This is called as canonical collection of items, LR0 items. These are called as every collection we kept a state here. So we have total 5 collections. That's why we have 5 states. Either you can maintain these collections or you can maintain states, is your choice. But both are same. Any doubt here? Now once you construct, we don't know whether the grammar is LR0 or not. We have a way to check. We have a way to check whether this grammar is LR0 or not. For that, you need a conflict checking. We have 2 types of conflicts, SR conflict check, RR conflict check. If you want to check SR conflict, just look, is there any state has shift item and reduced item? SR means shift reduced, S means shift, R means reduced. If any state has both shift and reduced, then that is having SR conflict. See, no reduced, oh this is not going to be reduced. Never assume it is reduced. It is acceptance item basically. Special reduced. This will never produce a conflict. It's acceptance item, special item. But remaining all are, this is reduced, but don't assume this is reduced because it's not your production. We have taken special. Okay? And no reduced item at all. No reduced item here. But one reduced item, when you have one reduced item, you will never have a conflict because reduced shift, reduced other reduced. Either 2 reduced should be there at least or 1 reduced other should be shift. But in all of them, when you have a reduced, nobody else is there. That means you will never have a conflict. When do you have a conflict? A reduced is there, right? Another reduced is there, then you will have a conflict. Or shift item is there here, you will get a conflict. So in this, no state has SR conflict and RR conflict. No state. Because every state is not having reduced. If it is having reduced, no other item is there. Clear? Here, no reduced, even though you have a shift, but there is no reduced. So if a state has shift and another one reduced, then you will have a conflict, SR. But here no SR conflict RR, here no RR, no SR, nothing, right? Single item is there, then you will never have a conflict because single item never produces a conflict. So when you see the single item, you don't look at it, just look at this 2. 2 items, there is a possibility of a conflict. Right? Oh, SS we never look at. SS we never look at. SS is not a conflict at all. Everybody, if you have 2 shift items, we will never have a conflict because both shift will be analyzed in future. Because both of them, if you have 2 shift items here, right, both will go in this path or they will go different path. Only 2 types of conflicts in entire bottom-up parsing, either SR or R conflict. When there is no conflict, then what is this grammar called as? What is this grammar called as? It is LR0. Just you want to say LR0, you need to do this much. But do you know in the exam how you do it? Are you going to do this much? See that, how you are going to do in the exam. I'm just taking the same grammar. See how quickly you can do it. You don't know whether it is LR0 or not. How quickly you can do it. See here. S dash derives dot S. Begin. Because of S, add S productions. And small a will not give you any productions. So close it. Initial state. S. Oh, only one. Leave it. A. Oh, you are getting more. So write it. Write it. A dot A. And A, how many productions are there? Only one. because of this A. That's it. And A, only one, don't do it. B, only one, don't do it. Then C, there is no reduced item, there is no reduced item, there is no reduced item, so no conflict. That's all. You can see and answer it, it is LR0. Is that clear? If you really want to construct the diagram, you should do only this much, not everything. Because single items, you no need to write. Just assume they don't have any issue. Everybody got? Come on, come on. In the exam, you should learn how quickly you can identify LR0. If really you needed this diagram, you use the shortcuts to understand the number of states, to understand the conflicts. We don't construct the whole diagram in the exam. You should use your own approaches to minimize the time. Because putting every diagram and doing these things takes a lot of time, Done? Okay, let's go for the second example. So we got one is LR0, right? So now look at another one. Can you try on your own this one? I'm just doing it, but do it on your own. Look at later. If you don't understand anything, let me know. That's all you have to do. Number of states, if they ask, 1, 2, 3, 4, 5, 6, 7. 7 states. If they ask any conflict, here no conflict because no reduced, but here RR conflict. What is it? RR conflict is there. So what we say, one adequate state means one error state. Exactly number of conflicts we can't answer without considering the table. So we state how many states are having conflict. One error state. Adequate means some conflict is there in that. One adequate state means there is an error inside. There is a conflict inside. Okay. But number of conflicts they don't ask. They ask, do you have SR conflict? Do you have RR conflict? That's all. But how many SR, how many RR? With this knowledge, you can't answer it. Don't assume one RR conflict. You do not know exactly. This is not one RR conflict. In the table, there are so many RR conflicts will be generated. In the diagram only looks like this state is producing RR, but this state might producing so many RR conflicts. You do not aware. So remember that. Don't ever say one RR conflict. That is a wrong answer. Are you able to see? Looks like one RR, but in the table, this might give you 5 RR conflicts. You don't know that, because in the table this will participate in so many cells. That cells will create a conflict, and these cells will be looking for the lookouts. This LR0 has no future, no knowledge, no prediction, so entire row you will be having the conflict basically. So are you aware of what I am saying? So do not compute number of conflicts, only compute how many states are participating in the conflict. Okay. I saw some of the test series, they ask how many conflicts. This is absolutely wrong question. Okay, but if they ask, you must depend on the table and answer it. But they're still answering with the diagram. It's not correct. Exactly. So cannot say correct, Chanchal. Those people who know how to consider the table, they will understand this will not one RR conflict. You will be having in the table, which row it is? Let's say 0, 1, 2, 3, 4. That fourth row, you will be having so many terminals. Let's say A, B, D. A, B, D, dollar, let's say. In the entire, you are going to say, let's say, this is which production? 1, 2, 3, 4. Third production, fourth production. Then you will be writing R3, R4 everywhere. That makes lot of conflicts. You need to find out how many terminals are there. The entire row you are going to give R3 and R4. It will create the 4 conflicts. This makes much time and you can't answer by considering the whole table. But if you have the awareness of table, now number of conflicts here going to be 4. But that needs a knowledge of different level, right? If they really ask number of conflicts, that's a table dependent, not diagram dependent. Yes. If those people who are able to construct the table, just remember, compute the number of terminals including dollar. Okay, 4 terminals are going to come in the action table. Then you will be going to give this production and this production in entire row. So you will be having the total 4 RR conflicts. Are you clear? So it's a much complicated question. Really, it looks like 1 RR, but not actually. It will be 4 RR conflicts. But that, how do you answer it? By designing by table construction only you will understand that. Not from here. That's why the state diagram cannot help you to find the number of conflicts. So you need to know table construction. I believe this question never comes in the exam. Okay? No. If they ask, it could be very easy question that can be answered from here. Okay? So far such questions were not, even the whole diagram the question was not there so far. In the whole diagram, this whole diagram questions are also not there. They never expected you should draw the diagram. You could have been answered without drawing the diagram most of the gate questions. Okay? Yeah. That's why you should know, right? Blindly you cannot apply the theory that you study from the books. In the gate exam you have very less time. If you keep on doing all of them here, it might take 5 minutes, 10 minutes to answer. Okay? If they really ask, you find other way to solve it, or you follow this kind of approach. Now, is that grammar is LR0? Now we conclude, oh, it is not LR0. It is not LR0 grammar. So you cannot construct LR0 parser using this grammar. This grammar might be, representing some famous programming language, you don't know, right? So you can't implement for this. So you need to change this grammar, then you need to build a parser. Yeah. After viewing, after considering the table, you can answer exactly what is it. Great. So anybody is having the doubt in LR0 jaldi, so that we can go for SLR1. Anybody is having identifying LR0 grammar or not with the help of diagram, remember that. In that, do not try some of the things that I told you just now. First you should know how to compute all items in the state. That's very important than anything else. Like you don't know exactly, right? S dash dot S is there, and S, you need to look at exactly this position, not any other. Right? Exactly this position only you need to look at. If this is non-terminal A, then A productions will come. A productions will come. If this is small a, nobody comes. If this is a B, then B productions will come. And here you have D, then nothing comes. So always focus on the first position only, nothing else. If the first position is non-terminal after the dot, then all the A production should be here, because this creates all the A. If you see B after the dot, then B production should be here, and this is applicable to every state in the diagram, right? If you have a state, if you have 100 items, then each item this closure is applied already. Clear? You cannot ignore even single item in the state. Every item is important when you construct this diagram. Clear? If you miss single item, after dot, let's say A dot B is there, and because of this, B production should be available in the same state. If you miss that, then this is not a proper diagram. Clear? Okay, let's go to SLR1. SLR1 grammar, if you want to check SLR1, right, you will use the same, use LR0 diagram only, or construct LR0 diagram only. You don't construct SLR1 diagram. Okay, construct LR0 only. That's an easy way. But then check SR and RR conflicts separately for SLR1. Okay, just small change. You have here different conflict rules. Okay, somebody else. After dot, if we get non-terminal, sir, that's what I'm saying now. After dot, if you get non-terminal, you should have all that productions here itself. That's what I'm telling you, right? After dot, if you see the non-terminal, then that non-terminal production should be available here by placing the dot. That you should never miss. This is only the concept you have, right? In whole construction, this is the only concept. You have a state, in that you have this item, after dot is non-terminal is there, the non-terminal, all production should be added. If there are 5 productions, all 5 should be added by placing the dot at the first. And this concept not only for this, here also you need to apply again. If you have a B here, all the B production should be added. So that is applied, recursively you need to apply, right? That's the rule. Okay, let's see. Now what I am going to do, SR conflict, how do you check? RR conflict, how do you check? Only these rules are different. Only these 2 rules are different. Now, when you are checking SR conflict, right, this is the shift item. This is the reduced item. So now one shift item is there. Shift item is something like this. X derives some alpha dot. So after dot terminal, and don't worry what is beta. We don't care. Alpha, beta, may be something, may not be something, anything. Okay. Reduced means something like, let's say, y derives, reduced means dot is at the end. And others may or may not be there, we don't know. Okay, others may or may not be there, we don't know. When you have these 2, LR0 says it is a conflict, but SLR1 will not say, because 1 means, oh, it has a knowledge. What knowledge? The follow set. Now this T, is it coming here or not after dot? To check that, for this you compute follow of 5. If that T belongs to the follow of y, means who is coming here. If it is belongs to, means if this T is coming here, then it is a conflict. Then we say SR conflict. Then we say SR conflict. Otherwise, no. Everybody, here we need to compute little bit follow set computation. Previously you said conflict, now we don't say, because after dot terminal is there, dot is at the end, shift item, reduced item, we said SR conflict in LR0, but here we have a knowledge. 0 means no knowledge, 1 means 1 terminal, 1 token, you can understand. So if this T belongs to follow of y, because after dot nobody there means follow of y is there. So T belongs to follow of y, then it is a SR conflict. Correct? T should be belongs to follow of 5. So this is the rule you need to compute, or you need to check for every grammar. There you want to check SLR1. RR conflict. RR, both are reduced, right? It's reduced 1. Let's say this is a reduced. Reduced means, let's say X derives alpha dot. Another reduced should be there, then only RR conflict, right? Y derives alpha dot. See that after dot nobody is there, and both are there in the same state, and remaining may or may not be there. Then if these 2 are producing conflict, then you must see follow of X, follow of Y, because after dot what is there, that is your target. That X will tell us, Y will tell us. If follow of X intersection follow of Y, if you see anything common, you will get not empty. Then we will say RR conflict. Where? In SLR1. Everybody, these 2 rules are important. These 2 rules are important. Okay, for understanding this, let's go back. Go back and check here. Do you have RR conflict? Do you have RR conflict in LR0? But let's see, do you have RR conflict in SLR1? Do you have RR conflict in SLR1? Check follow of A. You need to do right, right? Follow of A, follow of B, compute from the grammar. What is the follow of A? Small a. What is the follow of B? Small b. A intersection B, is it empty? A intersection B, is it empty? That means no conflict. No conflict in SLR1. No conflict in SLR1. That means this grammar is one adequate state in LR0 but no adequate state in SLR1. That means it is SLR1. That's why SLR1 parser is more powerful than LR0. SLR1 parser can understand this grammar, but LR0 parser can't understand. Is that clear? How to check LR0, SLR1? Come on, quick. Only checking the conflicts is different for both, but diagram construction is same. Are we ready to check both of them? And when the grammar is LR0, will you check SLR1? When the grammar is LR0, will you check SLR1? And without knowledge, you crack the gate. When you have the knowledge, you can't crack the gate. You can, right? This is the same concept. LR0 means without knowledge, you proved it is LR0. Then with knowledge, you can prove it is SLR1. Okay, the relation between LR0, these are LR0 CFGs. So one example was here and one example was here. We computed, right? Other examples may come anywhere. 1 and 2. 2 is outside, 1 was inside. And SLR1 CFGs here. And LELR1 CFGs comes here later on. Later on. We did not start it. And in future we will see LR1, that is also called as CLR1. If I say the grammar is LR0, there is no need to check other, because this grammar is SLR1, this grammar is LLR1, this grammar is LR1. Is that clear, everyone? Once it is LR0, no need to check other grammars, because by default it satisfies. The first example, we got answer here. The second example, the answer was here. The second example, we got SLR1, but it is not LR0. We keep trying that. Okay. Third example I am taking now. Third example. Okay. I'll put there in the diagram. Third example. So if I get something like this, S derives A or epsilon. So now let's look at S dash derives dot S. Correct? And S derives what? Dot A. S derives dot. Don't write epsilon. See, dot epsilon, epsilon dot, dot, all are same. There is no difference. It means after dot no one is there. That is the meaning. Everybody, don't write epsilon now, because this is the deterministic diagram. Their epsilon transitions are not there. Everybody? Turing machine will be on Monday. I told, right? The second part TOC revision comes on Monday evening. I was planning to make it from 8 or 7. I'm planning. S, one item, so no need to write. A, one item, no need to write. That's all. If you keep epsilon, you might do the mistake. You may take the transition on epsilon, but epsilon transitions will never be there in deterministic. So here it is very important. Dot epsilon, epsilon dot, dot, all are same. So better to keep the dot, because you might take epsilon transition wrong. Epsilon transition never be there in the DFS. Okay. Now you look at, is this LR0? See now, this item called as reduced item. Is that correct? This is reduced item. This is shift item. But this is not shift or reduce. This is a state item. Okay. Now this two produces SR conflict in LR0. Where? In LR0. So this is not LR0 because we got a conflict. We got a conflict. But to check the SLR1, you need to do something. This A, is it coming in the follow of S? Is that A belongs to follow of S or not? Follow of S is what? Compute dollar only. So A belongs to A, does not belongs to follow of S. That's why no conflict in, no SR conflict in SLR1. That's why, of course, no other possibility is right. Only this one is their possibility. So it is SLR1. So another grammar we got another grammar, that is third example is going to fit here. The third example, second example here, this is the first example, right? So one we have seen LR0, so it satisfies. 2 and 3 is SLR1. But if it is not SLR1, right now we can't conclude. Okay, remember that too. Any doubt here? No conflict. We have a conflict, we have SR conflict in LR0, that's why it's not LR0 grammar. We have no conflict in SLR1, that's why it is SLR1. Okay? Any doubt? Come on, so far. Any doubt? Now, can you try it? I'll just try. Look at how I do it basically. We don't need to do everything. So we'll do very minimum and need to find out the right answer. Don't write every production, so it takes much time. But don't forget to put the dot. I think I did small mistake. Okay, I'll just be changing the grammar, that's it. It's B, I need to write, just I changed it. Okay, now look at, that's not over because dot A dot B is there. So A productions comes, B productions comes, and when you read F, both comes here, right? So we got a conflict in LR0. Then directly you can say now, if that question depends on only LR0, answer is over. It is not LR0, so answer is over. But that options also having SLR1, then you need to do little bit work. A, only one. Then after A, B comes only one item. So you should know that logic. Why we are having only one item. If you don't understand, write everything. When you don't understand, do everything. When you understand, make a shortcut. When F comes here, again you go there. Correct? So now we got a conclusion that is definitely not LR0 because here they produce RR conflict in LR0. We have it. But for SLR1, you need to compute follow of A and B. You need to compute follow of A, follow of B. So here look at follow of A. What is follow of A? follow of A is a, small b. What is the follow of B? Let's look at small b and small d. And when I do the intersection, follow of A, follow of B, we got non-empty. Means there is something common, that is B is the common. So not pi. It means we have RR conflict, RR conflict in SLR1. So this is neither LR0 nor SLR1. So this grammar is not LR0, also not SLR1. Everybody? If there is a possibility of SR conflict in shift to production after dot, that's not a shift. That is not a shift, yaar. What are you doing? No. So do not consider as a shift. See this. See, this is not called a shift item. Don't take at all. This will be checked in the future if you have any conflict. So please don't look at this. So when you have, see here, in this, you should know what is a shift item. Only this is a shift item, shift item, shift item, shift. These two are not called as shift item. The SR conflict is about shift item, right? SR conflict is about shift item. After that, if you have a non-terminal, please don't check that item. That will be checked in later, not in this state. Okay? That is not going to use as, it's not called as shift items, right? It's not called as shift items. They are state. They correspond to some other meaning. Okay, don't use that kind of conflict check. If you have shift reduced conflict possibility, then this kind of items only should come. This two should not come. These two are not called as shift items. Okay, don't compute for first of A, first of B. No. This is not a shift item first. So this will produce a conflict possibly, but this will never produce a conflict. Remember that. Okay, don't use that. Where are we? Yeah. So we have the fourth one somewhere. We don't know exactly where it is. The fourth definitely not inside. Somewhere here we don't know. Somewhere the 4 present. Somewhere the fourth one present. But we know it is not SLR1, but we don't know clearly, is it LLR1, is it CLR1, is it not CLR1, we don't know. But somewhere is present. Is that clear? So I'm not able to fit the 4 here. Unless I learn this 2, I can't answer about the 4. Okay. Are we ready to go to the next one? Now I can tell you why this is not SLR1. See, what I am trying to do, I am trying to compute follow of A, follow of B, but actually if I come with this path, follow of A is different. This A is a small a. So from this path, follow of A is a small a. From this path, follow of A is a small b. And when I ask here, you are computing both of them. You are not maintaining two different states here, and you are looking at both of them. So when I compute exactly by the paths, right, then this A, this B will not be combined like this. Follow of A, I said A comma B because I am looking at both of them. But this path and this path is different. If this path I maintain separately, then you will never have a conflict. So here the problem is, when I ask follow of A, you are combining all the paths. You are depending on the grammar rather than the paths. That's why this SLR1 is not powerful. But when you go for CLR1 and LLR1, they will depend on the paths. They will not combine like, of course LLR1 will do that, but CLR1 will not come here, will maintain a different one. If their lookets are different, it will maintain separately. So we'll see that the CLR1 why it's powerful, because like SLR1, it will not combine blindly. See, on F, you're coming here. Why are you coming here? You're not looking at who is after coming, right? But lookets is going to maintain the follower for every production. That diagram is slightly lengthy compared to this one. Yeah. Okay, Sreyank, yes, it will go to the go to column or go to table, correct. Now are we ready to compute or construct the CLR1? Later only LLR1. For this I will take the same example but take much time. It takes much time. Okay. For that, let me take simple ones. Simple ones not need, I guess. Okay. Let me take the same one. S derives. I did not remember the whole grammar also. Okay. So this is the grammar. We know the LR0 diagram, but now we are not going to do construct LR0. Now we need different diagram. See LR1 first. See, LR0 item and LR1 item, both are different. If you have a production, let's say A derives, let's say A dot something like that, A dot B. This is called as LR0 item, but here you will maintain something different. A dot B, comma, you will maintain some lookahead portion here. You will maintain your lookheads. You will compute. This portion will compute for every production separately. This is already, we know it's a common part. It's a common, right? We have for LR0, LR1, it's actual production only. But this additionally you maintain. Why? This is exactly same as follow of A. Follow of A, no need to compute from the grammar. This is computed, depends on how you go from the paths. So every path, this production may have the different lookouts. It depends on the path. Yeah, conflict checking are same, not conflicts. Conflict rules are same, but not the conflicts. Who is that? Torpada. Conflicts are not same. Checking the conflicts rule is same, but conflicts may vary. Okay. So use that statements properly. Everybody, LR1 item will have the separate the lookahead portion, but LR0 items and these items we use. These items we use for LR0 and SLR1 parser. These items will use for both CLR1 and LELR1 parsers. So LR1 items we use for CLR1, LELR1, and LR0 items will use for LR0 and SLR1 parsers. That's why the same diagram I have used for SLR1 to check the conflicts. Clear this point? So far it was so easy because we did not maintain the lookheads. Now we are going to maintain. Now, how do I compute here? See carefully, the first item is so easy because its follower is well known, that is a dollar. That's all we know, nothing else. Now, because of this, you need to compute. See how you compute. Let me write that rule first. Suppose you have something like this, x derives alpha dot y beta, and let's say this is gamma. That's a lookahead. Otherwise write capital L, something like this. Now what you want to do, because of this y, you will compute y productions, right? You will write all the y productions by placing the dot. And here you have something, don't worry about what is there, comma. How do we compute here? How to compute this portion? How to compute this portion? How to compute this portion? Exactly will depend on what is here. This beta comma L means just assume beta L only. You will take the first terminal who comes from beta L. That's it. If you want to look at the examples, look at this first before starting. Okay. Suppose I have like this, A dot A, B, comma, C, R, D. So these two are lookheads. L is nothing but, you can write C comma D or C R D, it's your choice. Now, capital A productions we are going to write something like, let's say, dot, some alpha is there. So how do we compute? This is B BC, BD, that's the meaning. BL, so B comes here first. Only B comes here. In case, if you don't have that small b, you have directly C or D. Then capital A production, let's say something is there, we don't worry. And how do we compute? You will write C or D only because nobody there after A, so same thing you will copy. So look at here, the C or D you can also write other way, C comma D is your choice. Okay, either this way or this way, both are fine. Now after A, if somebody is there, compute and put it. If nobody there, copy paste. Clear? That means that beta is there or not, that depends. If beta is epsilon, copy paste L. But beta sometimes giving, sometimes not giving, then you need to find all possibilities. Is that clear? How you should compute. I'm only looking at how you compute this one. This portion, how do you compute? Okay? By depending on what is there here. By depending on what is there here. Beta L, beta is there, then take it. Beta is not there, then L will be the answer. Everyone? Are you able to understand how to compute the lookets of A only? How to compute lookets of A, not S. S is given, assume that. How to compute the looket portion of A. Lookets of A, I am helping you, okay? Come on यार, कुछ तो respond करो यार, किसको पढ़ा रहा हूँ मैं? Concept पढ़ा रहा हूँ, right? B you will take. Are you not looking this? Are you not looking this? If you are having A, B, here C, you will write A, B, C, right? Who is the first? A only, na? Use this concept, yaar. First of beta L. Beta is already A, B. Who is the first of A, B, C? A, right? So you'll get A now. Correct? Answer is there in front of you, but you are not applying it properly, okay? First thing, whoever comes. Because for bigger grammar, I can't explain in detail like this because we are going to deal with many productions there. Now see, here I did not compute anything because this is by default $, for this, right? I did not compute, but for this S, I need to compute S dot AA. I need to compute there. S derives dot BB. I need to compute there. S derives dot CAB. S derives dot CBD. All of them I will depend on this one. So after S only $, is there. So I need to copy from here. That's I'm doing here, right? $, $. So all of them it's computed from here. And for this one, right, now here you have capital A. Because of capital A, I am writing capital A productions. How many? Only one. But how to compute this? That depends on a $, that I need to come here. That's A. Is that clear? I got A because A is the first. Now B is there, and B I am going to write, that is dot F. Then who is that? Dot F. So now you need to look at this thing. And who is the first one comes here? B. And this you don't do because the terminals, they are terminals, we don't do anything. So that's all, this is the initial state. Everybody got clarity how you should compute step by step. These 4 productions are coming from here, so their lookouts depends on here. This production is coming from here, so its lookout depends on after A. This production is coming from here, so this lookout depends on this one. And after A, B is there, we don't look at, because this A is not responsible here. This A is responsible in the next state, because after dot C is there, we never look at this A. Everybody clear? Don't look at this capital A, this capital B, because that is not after immediately. After the dot immediately, not present. This two will give you nothing, and they are not deriving anything. Okay, they are computed from somebody, but they don't give you additional. Okay, if you understood, I have no issue because everywhere the same principle. If you don't understand, please work on. Okay, S, how many are coming? Only one. Why do you want to do it? Don't do anything. Just copy paste only, right? dot moves and dollar. No, not computed, just move there. Only dot comes here to here, that's it. And when A comes, S derives A dot A. See, you need to compute, you need to apply the closure. Because of terminal, you get nothing. Okay, that's it. And if you want, you can expand completely now. A, then you will get one thing, that's it. You write it as it is. But dot only moves. Capital B, only dot moves, that's why I'm writing nothing. Only dot is moving, that's it. Only dot is moving. Here you need to write. C is there. Then what do you write? S derives C dot A B comma dollar. S derives C dot B D comma dollar. Now you look at here, can you see that capital A is there, capital B is there. So you need to write A productions, B productions also you need to write. But after A, B is there, so B comes here. After B, D is there, so D comes here. And F cannot expand further. Okay, so that is when you read a C. And of course this comes later. A is only one item, move it. D on B only one, and capital B only one. So don't have any issue with this. Only one. And here F need to be read. And then when you read F, what comes? F dot A comma B. So A derives F dot. Copy paste, right? Don't compute anything. F dot. Right? And here when you read F, A derives F dot comma B, and that's definitely different from this. So that's why you cannot have this transition here. You should maintain separate state for this. Why we maintain separate? This item has a lookup, this item same items, but they're having different lookups. That's why you can't go there. Okay, so now you see the lookups are computed based on the path. Follow of A is available here, follow of B is available here. Previously follow of A, follow of B means you looked at grammar. That's why there was a simple LR1. So you look at grammar, you don't look at the path. That's very simple, it is very simple. But here canonical means exact. So the lookups are computed based on the exact paths. Okay, now need to check. Anyhow we know the same grammar, right? It is not LR0, not SLR1, but CLR1 is check. RR possibility, but do you have any common terminal? No. Do you have any common terminal? No. That means no RR conflict. Everything is available here. Follow of A is here, follow of B here. No need to compute that. So just check. No common, no common. That means no RR conflict. No RR conflict. No RR conflict in CLR1. And here also no RR conflict in CLR1. How do you check? How do you check? If there is a reduced item, of course two types of conflicts, right? SR conflict, rule is same for both. For CLR1 and LLR1. Okay, LLR1 I'll start slowly, but for both of them rules are same. SR conflict means shift item is there. It looks like something. X derives alpha dot T beta, some look at here, L1 let's say, and reduced item. Y derives alpha dot, there is some look at 2. So how do you check the conflict here? Very simple. Here T is there, here L2 is there. Just check T is there in L2, that's it. No need to compute fall of Y because already there. If T belongs to L2, then conflict. I hope you got the point. No need to compute the fall of Y because already there. Same like SLR1, there you compute the fall of Y, here you don't compute, that's it. You have one reduced item, you have another reduced item, like X derives alpha dot some L1, Y derives some alpha dot L2. Now the issue is this L1 intersection L2. Instead of checking fall of x, fall of y intersection, here you will check this between. You check this two only. So if L1 intersection L2 is not empty, that means it is a RR conflict. Everybody, this rule is same for both CLR1 and LLR1. Clear? So previously we got this problem. A to F dot, B to F dot. Here we are checking any common terminal here. No common terminal. If you see previous example, A intersection B empty, B intersection D is empty. That's why no conflict in CLR1. That means this grammar is CLR1. Which one it is? CLR1. It is CLR1. What is it? CLR1. Everybody got CLR1? Yes, L1 intersection L2, if you have anything common, that is not equal to pi. Done? I'm just editing the slide. I copied it again. Okay. Same taking, but next time. Now I'm just constructing what? What LELR1 construction. What is it? LELR1 state diagram. Almost same, but do you have any two states which are having same set of items but they have a different lookets? Of course you need to look at everything. If you don't look at, then you will confuse. Every state you have to look at. Any two states are having same set of items but you may have different lookets, that's fine. Just look at every state with other state. Just compare. Any two states are having same set of items, but their lookets may be different. So I'm numbering to understand. Okay, let's say this is I0, I1, I2, I3, I4, and this is, let's say, I5. Numbering is your choice. How do you want to give? I don't have any problem with the numbering. You decide. I11, I12. Total 13 states are there, right? So now I10 and I5 are actually having same set of items, but they have a different lookets. So you need to combine them. How do you combine? I5 and I10, you combine into single state. So when you combine it, what happens here? So I5 and I10. So before this, right? I'm just writing before this. Here, I5 and I10, so both are actually in CLR1. That is, A derives F dot, B derives F dot, and the lookets I will copy later because I did not remember it. But we have the same items, right? We have the same items in both. Here lookets are different, it's okay, but you can combine them now. So what are they basically? A, B, B, D, okay? A, B, B, D. So this both are there in CLR1. Now we are making LELR1. What you do? We combine. So we'll create a new state. Let's say I510. The single state will merge. How do we merge? A derives F dot and A union B. So A or B comes. And B derives F dot, B union D, B or D comes. So this is what is in LELR1. So we merge the two states, doesn't matter, no need to be too reduced, right? But these items are exactly same, lookets are different, so we can do the union of the lookets. We get the new state, okay? Now in this diagram, we don't have the two states. What we have, So we can copy here A or B, that D you can copy here, and here this one we can delete, and on F actually you can translate here, and this is the new state I phi10. So this is the LA-LR1 diagram. This is what? LA-LR1 diagram. But diagrams may differ, but checking the conflicts is same. Now you have to check the conflicts, right? You have to check the conflicts, right? How do you check the conflicts now? Check this. Two reduced items. A union A comma B, B comma D. So here A comma B is in 1 here. Here B comma D is there. Intersection you have to do. O is not equal to pi because B is the common. B is the common, right? So that's why it is having which conflict? RR conflict. In LA-LR1. It means this grammar is not LA-LR1. Everybody? It is not LA-LR1. Rules are same to check the conflicts, but the diagram is not same. It might change sometimes, it might be same sometimes. Okay? So this grammar is going to be there. What is the number? It's same, right? It's the fourth one only, but I took many times, I guess. Fourth, fifth, right? That fifth is also fourth only. I'm just going back. I'm just going back just to see. This fourth only we are doing again and again, right? Fourth, we made it as a 5. We made it as another one, sixth. This is 6, but it is 4 only. So now 4, 5, 6 are actually same problems, but we did multiple times. Now where it stands? Somewhere it is 4, but we got the conclusion that is outside SLR1, outside LLR1, we got the answer here. Here it is a 4. There it is a 4. Everybody? We got the answer for the 4. It is there in CLR1, but it is not LLR1, even it is not SLR1. Done? So everybody got the concept of construction? Come on, quick. Now we need theoretical points. Now don't ask me examples and practice. In the exam they don't ask all these things. Only relations we need. You know how to compute the closure, you know how to compute the go to, that's fine. You know how to compute the locates for every item, that's fine. They don't ask whole diagram. See how much time it took. Okay. Now we'll go for the theoretical points. Any doubt so far? And in the exam, this kind of questions never be there, lengthy questions. Always the questions are very easy from compiler, but learning will take time because you should know how to construct, right? Then only you can answer theoretical questions. Okay, now we need to understand theoretical points. So now the first theoretical point. LA-LR1 grammars. So many grammars are there, right? Here so many infinite grammars are there, infinite. And including these grammars, we are talking about CLR1 grammars, also called as LR1. Okay. Understand here, point. What are these grammars called as? Anybody? What are these grammars called as? What are these grammars called as? These grammars. What are they called as? CLR1, but not LA-LR1. Everybody agree? There is a theoretical question from this. Come on, come on, come on. Are you ready? Go on, yeah. Is that clear, everybody? These grammars are inside the CLR1 class, but outside the LLR1 class. Here again infinite grammars are there. Again infinite grammars are there. Now these grammars have a relation, right? if G is CLR1 but not LLR1, then for this grammar, if you construct LLR1 diagram, something going to happen. I'm just writing here, if, read that theory. Oh, where do we have the space here? Let's say if G is CLR1 but not LALR1, right? Then if we construct LALR1 diagram, LALR1 state diagram, what do you observe? Anybody? Then dash conflict exists. Clearly it is true, only one type of conflict you will get for LALR1. Anybody? Another one. That's the first point. Answer that. If G is CLR1, I am not saying what is it. If G is CLR1, then if we construct LALR1, then dash conflict possible, don't say exist, conflict possible. And dash conflict and dash conflict impossible. So these are the theoretical gate questions. Anybody? Here, this grammars CLR1 construct no conflict, but for this, if you consider LLR1, right, they have a conflict, but only RR conflict you will be having. You will never have SR conflict because some states are merged. Because of that, this conflict exists. And when you merge the states, you will never have SR conflict. Remember, when you merge the states, you will never have SR conflict. Conflict is possible RR, but SR impossible. SR impossible. Here we have a theoretical logic also. RR possible, but SR impossible. But if you know exactly the grammar is here, RR definitely there. That is why it is not inside the LALR1. If the grammar is not inside the LALR1, but inside the CLR1, then definitely that is having RR conflict. These two questions are different. If you can understand, right? Here look at the grammar, I am saying CLR1, which is not LALR1. Here grammar I am saying only CLR1. Means it can be anywhere. It may be here or here or here, doesn't matter. For this one. For this one, clearly I am talking about outside. Everyone, there's a very interesting question from this class diagram. When the grammar is here, definitely you can't use this LALR1 approach. If you use it, it will send away because it will generate RR conflict. But if the grammar is here, no conflict. No conflict. Okay? But in general, I am talking about what conflict is possible. RR conflict possible and SR conflict impossible. Sometimes RR conflict also not possible when the grammar is here. CLR1 means this might be possible, right? For this example, this is also CLR1. For this, no RR, no SR. But if it is here, RR possible, SR not. Okay? But to understand this, you need to take the rules and you need to apply the intersection concept. Okay? Let's go for more relations. Grammars I am talking about first. Grammars. Relationship with the grammars. Can I say LR0 CFG is SLR1, CFG is LALR1, is CLR1, is unambiguous. So this relation exists. Okay. There is another relation if you take simplified LR1, LL. If you take simplified LL1 CFG, then this is going to be always, the simplified LL1 CFG is always SLR1 CFG. And LL1 CFG without unit productions, null you may have, without unit rules, without unit productions, this CFG is always here. If you simply say LL1, I don't know which CFG it is, then it is always CLR1. So look at this relationship. If you know LL1 is not having null rules, simplified CFG, then it is always SLR1. If you know LL1 is not having unit productions, then directly you can say LLR1. Right? But every LL1, don't know what is this LL1, may not be simplified, but it is LL1, then it is always LR1. So this grammars we need to understand. Relationship. It is just a grammar, one grammar I am talking about, one grammar. Is that clear? Rules? Then every LL1 is LR1, but if you know that is already simplified, every LL1 which is simplified, SLR1. Every LL1 which is not having unit productions, it is definitely LLR1, but may or may not be others, we don't know. Simplified means no null, no unit, no useless productions. Simplified, basically I use the word because I don't have null productions. So simplified, you can use the word, or you can use another one, LL1 CFGs without null rules. Without null rules, that would be sufficient, but simplified is the best name that I can use. Okay, that's the grammars. Parsers, when you look at the parsers, LR0 parser is less powerful than SLR1 parser, less powerful than LLR1 parser, less powerful than CLR parser. And LL1 parser, no relationship with them. LL1 parser, no relationship with them. If you want to relate, you can only relate with this parser. Done? Right, these two important points you need. And classes. When you are looking for the classes, right, then answer you need to know the set of all LR0 grammars. Set of all LR0 grammars, this set of all grammars is inside the set of SLR1 grammars. Set of all LELR1 grammars. Subset, set of CLR grammars. Subset, the set of unambiguous grammars. Okay. So any possible theoretical question from here, please answer without thinking, because this is very important for the bottom-up parsing concepts. LR1, not LR0. LR0 no relation, right? LL1, LR0 no relation. Some LL1s are LR0, some LL1s are not LR0. That's why no relation with that LR0 soul. But always LL1 you can say LR1. Yeah, good. Okay, let's have a practice. Okay, I can't draw the diagram for every question, but simple one. First one, S derives A. Answer all possible things. I can't answer all of them, but you can. LL1, LR0, SLR1, LALR1. Think about all possibilities. CLR1, ambiguous, unambiguous. Okay. So what else we have here? Left recursion. Don't know in the exam what do they ask, right? Left factored or not. Okay, that I'm not asking, not much important here. Okay. Let me copy this slide for all. Okay, I think this much is fine. Okay, can you answer the first question? First one, S derives A. Come on, quick. What can be the answer? All of them you take, whichever is right. Single production never create ambiguous, right? Never create recursion also. It's useful grammar, right? Useful grammar. So never creates no left recursion, no ambiguous, unambiguous, and it satisfies all of them. Single production will satisfy all of them. It's a very good grammar in the world. In fact, correct? Okay, not only this, I'm just taking one more example which will be the same answer. Okay, which will be the same answer. The second one, S derives A or B. Will it be the same answer? It's not ambiguous, no left recursion, and it is going to satisfy LL1, and because intersection is empty, and it's going to have no problem in the conflicts. Same answers for this one. But what is the difference between these two apart from this? Apart from this, this is LL0, but it is not LL0. Oh, what is this LL0? Because LL0 means if every non-terminal should have only one production, that will become LL0. So without knowledge it will choose. Without knowledge it will choose because it has only one production. Like S derives AA, A derives B. See, every non-terminal has a single production. That's LL0. But when it is having more than one production, LL0 is not going to satisfy, because LL0 means it has no knowledge of choosing the productions. If it is having two, it may choose anybody. So this will have a problem to understand ARB. But ARB can be understood by LL1, because it can look at who is going to come first, A or B. So accordingly that it can choose. But LL0, 0 means no knowledge. It has two things but don't know which one to pick. So it is not LL0. It is not LL0. So both of them are actually same for this, but they have the difference on their own, because it comes under LL0, it is not going to come under LL0. So it's one of the important example too. But both are having the same answers that side. Both are LL1, both are LR0 and everything. Okay. Anyway, don't worry about LL0 if you don't understand, that's fine. Third, look at this. Yeah, I'll just see who will answer it correctly. I'm waiting for the answer. So take time for 1 minute to understand all the options. Assume it is a gate model question. How do you answer it? you need to understand LL1. Is it LL1 first? In case if you see LL1, then all of them that that LR1 directly you can answer. Unambiguous you can directly answer. Not LL1, that means you don't have the shortcut now. If it is LL1, at least you can choose some of them. Not LL1 means you need to look at what is exactly it is. Is it LR0? We don't know. Is it SLR1? We don't know. Check LR0. Okay, don't worry about LL0. Just start looking at only the column. Whatever you have in the column, just look at them. Forget about LL0 right now. It is not LL0, we know that, very easy. Not LL1 you are able to say means it definitely not LL0. No, Durgesh, I think no. Don't say that. You need to check clearly. Previous one single production, that's why you did not do, but now you have to do it. Okay, look at how you do it. It is not LL1. How did you conclude? You are checking, right? Not LL1. How did you conclude? Because a first of A intersection first of AB was not equal to pi, because A is the common. Both of them A is the common, right? That's a not LL1. That's why you got the answer. LR0. Look at that. S dash derives dot S. And see here, first look at this. It is not ambiguous because you have a single positive for every string. Now S derives dot A, S derives dot AB, and now look at here. When you read S, you get 1. When you read A, see that two things comes here, A dot and A dot P. Here you got the answer. Here you got the answer, not LR0, because one is reduced, other is shift. Definitely not LR0. Only one item, leave it. Now you need to observe, we got answer, oh, shift, this SR conflict in LR0. That's why not LR0, but SLR1. Check this B. Is it in S? Check that. B belongs to in follow of S. B is not belongs to follow of S. So no conflict in SLR1. That's why once it is SLR1, definitely remaining 2. And is it left recursion? No. Are you clear? So sometimes it is required to construct the diagram, then do that. But that also done within seconds. Clear everyone? Because we got SLR1, so we can conclude the remaining 2. But if you don't get SLR1, then you need to go for other approach, the CLR1 approach. Correct? Because in the exam you don't have this many things. I am only creating this much difficulty. If you can understand this much, in the exam questions will become so easy. Right? Answer should be in 5 seconds. That's it. This question can be answered in 5 seconds. Only 5 seconds, all of them you can answer. Consider CLR1, Shivam. Look at the options. Good morning, Jatin. Look at the options. If the options demanding CLR1, then go. Otherwise not required. Only 4 options will tell you what to do. If they are only asking LR0 SLR1, the answer is not SLR1. Options will help you what to do, Shivam. Do you go to CLR1 construction or not? Option will help you. Aniket, that was the trick, right? Everybody knows ambiguous. When the grammar is ambiguous, right? Very simple. When the grammar is, this is the main focus. Ambiguous, grammar never be anybody here. But left recursion also failing here. This one you need to check. Check this, because left recursion depends on the type of the grammar. Check CFG. Oh, that is also left recursion. Left recursion. Now look at another example. Okay. Look at other example. Next example, you will not see the left recursion. Look at this. Do you have any left recursion? Do you have ambiguous? Yes, right. Because of ambiguous, remaining will fail definitely. And unambiguous, you can't say. Now you can't say left recursion also. Did you see? Previous one, ambiguous was the left recursion. Now this ambiguous is not having left recursion, so you should be very careful the last one. Last one, blindly don't choose the left recursion, because this grammar is ambiguous, but still it is not left recursion. Clear? Previous ambiguous was having left recursion, but this ambiguous is not having left recursion. Everybody clear? The problem is, if I go in very fast, right, you can't catch. If you miss any concept, right, I can't come back. See, I need to look at every doubt, and I need to explain. If I keep on going, right, so many people I need to ignore here. Anyhow, that's your choice. Okay, so I hope you understood the point, right? All the LR concepts. Now the last concept that we will go for okay, computing the operator precedence. How do you compute operator precedence? How many operator precedences are there? 3 types basically. One is less than, other one is greater than, other one is equal. Right? 3 types of operator precedence relations are there. Now you can compute with the help of many things. One, we can, or it can. Precedence relation between operators can be computed using context-free grammar. Second, these relations can be computed using parse tree. Third, this can be computed with the help of table also. In the exam, we don't know what do they give to you. They may give you table, they may give you parse tree, they may give you CFG, or they may give you theoretical points. English theory can be computed using some theory. You don't need this 3 also, right? Was all the 4th one you are asking right now? Yeah, is this ambiguous or not? You are asking very late, yaar. You can generate directly, or you can generate what, yaar? This way. Only one string, yaar, one string. Is there any other string that you can generate from here? Impossible, right? Only one string, that too 2 parse trees. That's ambiguous, yaar. Very simple. Okay. Ready? Okay, let's take some example to understand. Okay, first example. Suppose I give you E derives E plus T, or A, T derives T star F. Okay, wait. F star T, or B, F derives C. Now you need to compute so many things here. Anybody knows how many things you need to compute? what is the plus relation and star? What else you have? That's it, right? Plus star. Of course, terminals relation we don't need. We only look at the operators now. That means 4 things you have to look at. What is the relation between 2 plus and plus star and star plus and star star? But this is ordered, means these are the left operators, these are the right operators. Remember that. If you by mistake look, this is the left, this is the right, you will never get the right answer. So you need to look at particularly if I have something, let's say E plus T. I'm going for this side, means this is the left operator. I'm going for this side, means this is the right operator. Is this left or right? Depends on which side you are going. Everybody? So that is very important. If I'm looking for this plus, that means this is a left operator. So that operators I should look at this side. Everybody got my point? So you need to understand, are you looking at left or right? What did you determine this example? Okay. Anyhow, let's see. Now first I want to look at the relation between plus plus. What do you mean by plus plus? Means, are you checking left associativity or right associativity? Right. The plus, is it participating in left recursion? Then definitely you will get left associativity. Why? You look at, you get A plus T, and other plus, will it come from left side or right side? From left side, no. That's it. That means if I have 2 plus, then which plus will be evaluated first? This plus is evaluated first, right? This plus is evaluated first. This side, there is a left plus and the right plus. Who is evaluated first? Left plus, means left to right we are following. So this is, when you are having left recursion, left plus will have more precedence, that this plus will have the more precedence, so we will represent with this symbol. The left plus has more precedence than right plus. Everybody? So this is the concept. You can use left recursion, right recursion. Look at this star. Star, when you look at, you are having the star is actually along with the right recursion, then right star will have more precedence. Look at that. F star T you will take, and this T will give you another star. That means who is having more precedence? This star or this star? This is the left star, right star, because order is very important. Right star. So we will evaluate this first. We are following right to left associativity. So star star is less than star, because the first star is less than second star. The left star less than right star, because it's following right recursion. So you can use this shortcut for the exam. In case if you see left recursion, directly left associativity. Left associativity means the left plus has more precedence than right plus. If it is right associativity, you may, not always. If no right recursion, still possible right associativity, remember. So if you have right recursion, then right associativity. Right means right operator has more precedence. So left star has less precedence than right star. Okay? Write properly that symbol. Got it? Now look at, now plus and star. Now if the plus is here, the right side is star, because operator is right side. So the T, can it give star? Oh, it can. Can you see that? It can give. Can you see that? Everybody? If you have the star, this is the right. Can plus come from F? No. That means when the plus is here, the star can come from down, means star has more precedence. So look at that, how I need to analyze. E plus T. This is the left. Then T, can it give the star? Yes. How? You can put F star T. That means star has more precedence, means plus is less than star. Speak properly. This is the left operator, this is the right operator. Don't mix up the concept. Now look at, take this production F star T. This is the right you assume. Then left operator, will it be possible from here? No. Then this production no need to look at. That's the meaning. Next, this star, and look at here. If you assume this is the left, then right plus, I'm missing this one. Can I get from here plus? No. No. Can you see that? If I assume this is a plus, right one, can I get this star from left? e to e plus t, and that t you can get here. So now you look at, I need a relation between star and plus. I don't know which one to look, this one or this one. So everything you should try, everything you should try, everything you should try. So construct any tree, there you find a relation. If you don't understand this concept right, because I'm not teaching compiler whole now, if you don't understand this concept right, only one thing. To star and plus, first star should come and plus should come, anything is fine. This string construct the parse tree from here. Look at that parse tree, fine, that's answer is over. Look at this string, maybe this string is a plus, I'm putting something like this. Let me write very simple one. I assuming a, and this is a. So this string you have to look at, that's all. Generate from this string, that's enough. Here you will find definitely answer. Here you will find definitely answer. Okay, I'm just trying for that string. You look at. See here. I want star plus, right? Star should come first and plus should come last, because this is the left and this is the right. Now generate using any side, because possible only one way if it is unambiguous. Okay, e plus t plus is came, right? Now that star should come from left only. That e, oh, not possible. No, right? Is it possible, guys? No. For that I'll just change the grammar, but don't worry, I'm changing the grammar, but result will be same. To get that, I'll just write here t. Now I'll have a t, I will have f, then star t. Then you will get it. Okay. Now you got this. A star a plus a. This is a, t to a. Now look at this. Who is having more precedence? Star. Who is having more precedence? Star. Star greater than plus, so greater than. But previously how do I find? That's what I was trying to explain. If you can find out some string which are having two operators, very easy. But if you don't know that, you're not able to get that string, then look at this one, answer will be here itself. Look how I am looking at. I take this production, e plus t. Now plus I, this one is fixed, that means it's the right operator. And from e, can I get the star? How I get? I can go for e plus t. I'll assume that this is not there. From t, I can go for f star t. Now look at, when I'm comparing this left operator, right operator, who is having more precedence? Star is having more precedence than plus. So in case if you don't want to take a string and verify, here also you have an answer, but don't know which one to look. Should I look at the star or plus? You decide. If I look at the plus, star must be left side. If I look at the star, then plus must be right side. So the production will tell you which side you should look at. So this is the one of the different concept in compiler. That's why compiler able to understand. You don't tell anything to compiler, but it knows what to do. First it will do something like this, and then it will do. Even you write a plus a plus a, it will understand, okay, this is how I need to analyze. Even I write a plus a minus a, it will understand this how, because C compiler was already built with the help of the grammar. Okay. So this is using grammar. Using grammar, you need to look at the right production right way. So are you looking at left or right? That is very important. As long as you don't know what is left and right, then you cannot have a clarity. Okay. But anyhow, you can always get from another concept. Look at this second concept. This concept only very important for you. I'm always looking at this only. That's why I'm able to get the answer. So I have something in brain. You can see that. E plus T and T star F and T star in my brain, right? This was working actually. E is E plus T, and this was given something like that. Now I was looking at this to get the answers. You see how I got the answers. Plus and plus. What is it? Left or right? You look at this. Two plus which are coming together one after other, and left plus has more precedence than right plus. That's why I got left associativity. I was looking at this tree. To understand plus is left or right, I was looking at this too. So this plus is having more precedence than right plus. The left plus has more precedence than right plus. Are you able to understand? Look at this. Left plus is having more precedence than right plus. Yes or no? This is the left plus, this is the right plus. That's why we should follow left right. Okay, now we look for the star. Look for the star. Two stars you have to look at. Don't look at here and here. Just look at, there should be one after other. In between, one operand is there. That's all. Max. Now look at, when I do have this, which one has more precedence, left or right? Oh, previous grammar might be different. That was F star T, I guess. You look at this. The grammar was slightly different. It was F star T. I just changed it. Okay? Both are not same grammars. Okay, similar. Now, two stars you take. Which star has more precedence? This is the left and this is the right. Right you can't understand first without left. So, left to right. So, star is left to right again. So, left associativity. Got it? So, here you need to compare. Which two operators you are looking? Just put left and right properly. Now look at plus and star. Plus and star. The many plus star, plus star, plus star. Look at any one is fine. This one you look at or this one you look at. But in between T is there, in between A is there. That's fine. At most one symbol should be there. This is the left. This is the right. Or you can also look at this. Left, right. Which one should be evaluated first? This star. Then plus will be done, right? So without this you don't have a meaning to this. Means star has more precedence. Star has more precedence than plus. You have only two, so you can say something like this. Star has more precedence, plus has less precedence. But when you have more operators, you need to tell star has more than which operator. Plus is less than which operator. So here only two are there, so I have no confusion. I can tell star is higher, plus is lower. Everybody got this point? So this is the parse tree. Even this parse tree, you can look at similar one, you can look at here. You will get the clarity. If you look at this one similarly, you can get an idea. E is there, E plus T is there, and T you have some F star T, and E you have E plus T. You can also look at here, and T you get one more F star T, and you can look at here. 2 plus is there, so plus follows left. 2 stars are there, star follows right, and plus star is there. Without star, plus can't evaluate, so star is higher, plus is lower. Here all answers are there. Everybody clear? How to compute the precedence with the help of the parse tree. The parse tree is very interesting in the computation. Okay? Parse trees are very helpful in understanding the relations. These two examples are enough to understand how to compute the precedence relations. We never find precedence if you are ambiguous. You'll get multiple answers, right? Only for unambiguous grammars we compute. When grammar is ambiguous, they will give you, you will follow them, that's it. Only for unambiguous grammars we can compute. That's why it is very important. There are two types of grammars: ambiguous CFG, unambiguous CFG. If ambiguous is there, they will write something like this: E plus E, E star E. You don't understand. If you want clarity, previously we did that. E plus T or T. T derives F star T, or F derives A. Oh, this is unambiguous. Here we can compute. We can compute here. Grammar has everything. Here we can't. Why? They should give you how to proceed. Here ambiguity is there. They must mention what is plus. Here we don't compute. Here they should say and precedence rules will be given. We don't compute. Will be provided. If they say plus is left associative, we will only evaluate plus is the left side. So left plus will has more precedence, so E will substitute. If they say star is right associative, then right star will be evaluated first. So here precedence rules will be given. Here may or may not be given. You can compute from here. So unambiguous grammars we can compute precedence rules. Ambiguous grammars we don't. They will be provided to you. Everybody clear? These are very helpful because you have very less productions. That's why you can easily express lot of expressions with the help of few productions. But here you are increasing the production. See, 1, 2, 3, 4, 5. Here 1, 2, 3. So ambiguous grammars are simple for representing expressions, but confused while deriving. That's why they are provided. Unambiguous are clear, but the problem is so lengthy. That's why compilers uses ambiguous along with specified one. Clear? If you are trying to compute here, multiple answers comes. Plus, sometimes says left residue, sometimes says right. Which one to follow? No, you can't compute from here. Everybody? Yeah, focus on what I am teaching here. Done? I think President's rules also you can do similarly. So with this, I think syntax analysis is done. Okay, one concept I am leaving: operator grammar, operator presence grammar. Just you may study on your own. Okay, what is the time now? 2:30. Need a small break before starting the SDTs. Come on. Need a small break. Almost 2 hours, right? We have taken the break. Yes. Now it's time 2:30. We'll meet 2:45. 2:45 a.m. This is, meanwhile, just have a tea and or walk sometime in case if you are getting asleep. Even I do the same thing. Okay, just take 5 to 10 minutes. I'll come back as soon as possible. Okay. Yeah, 10 minutes is also fine, but I'll come as soon as possible. But assume that worst case, I may come by 2:45. Yes, we are live, Ashit. Yeah. So here, how many of you are interested to continue now, or should I come on Monday, Tuesday, part 2, like for TOC and compiler? TOC any of part 2 is there. Similarly, should I come for the compiler part 2? If you really wanted compiler part 2, then we will do on Monday, Tuesday. Or Monday, both parts are Monday, TOC, compiler, Tuesday. Would it be fine? Because it will be hectic for everyone that making continuous. That's true, but we can do it. Yesterday only we did TOC. Now today we are going for long session, right? If you come up with the other day, then we can go with the last 2 topics very effectively. With this energy, last 2 topics we are teaching, right? That's why we had a good choice. Undisability Turing machine, we got another day. We are so lucky. Correct? Similarly, SDT and what? Intermediate code and code optimization. These 3 topics we can do effectively on either Monday or Tuesday. Because Monday we'll have TOC. It goes long, then we'll put on Tuesday. That's better. Monday, Tuesday, 3 to 4 hours minimum will take. We'll have. Would it be fine for everyone? So let others join, then we will decide. What about the part 2? So already 3 need to go for the duty again in the morning. Okay, so we'll plan this SDT, intermediate code, and code optimization. If you want runtime environment, this we will go for part 2. Most probably on Tuesday. In case if I prepone to Monday, just follow the schedule. Tuesday will plan, otherwise if it prepones, the Monday. Like Turing machine, undecidability, we have a part 1, part 2 on Monday. This one I take early, then CD also comes in the on Monday. I don't believe that Monday will come, both of them. It will be very difficult. So we'll plan Monday and Tuesday. Meanwhile, you go for the revision for other. Everything I'm beginning from only, right? Just well, I'm not going in the middle any of the topics so far. Okay. Then see you on Monday and Tuesday. Follow the schedule as per the planning. Timing mostly 7 p.m. or 8 p.m. Okay. Anything else you want to discuss before leaving today? Because for next few days it is very important, right? So today is almost Friday, Saturday, Sunday, 3 days. We'll have hardly 1 week for the exam. So this 9 days, how are you going to prepare for the exam? Yes, Shivam, what is your doubt? I'll also have a rest time to get more energy, right? Yeah, that's why I came back. Because I don't want to close the session without having. For you, it is very easy. Go slowly, topic by topic. Like you spend enough time on each chapter, and have a proper notes and proper practice problems. So you have enough time to practice. Okay, we have a lot of discussions. We can discuss a lot. That almost except 1 hour, how can I say? Almost all topics are relevant to our exam only. Some of them might be outside the context, like complexity theory, which is not there right now, but earlier we are having, right? Very few topics that some are added, some are deleted. You will understand, right? We are guiding here what are there in the topics. Those things we are teaching that are relevant. Not teaching, you can ask us. Last 15 years, most of them are relevant. But software engineering, web technology, that is related. Don't read it. Forget. Yeah. Sometimes they add topics every 5 years or 10 years. They decide it how long they want to keep same syllabus. Okay. For you, you just follow what we are teaching in the classes. Most of the PYQs we are taking, last 10 years we have taken here, right? Sound not coming? Sound is there, no? Oh my god. Just saying. Yeah, anything else? So how it's coming, right? Yeah. Suddenly I thought, did I keep in the mute? Yeah, Shivam, that's a good point. Those people who are yeah, difficulty in remembering, it means you are not giving enough time to understand the topic. See, what is our target? Okay, today 3 hours I want to complete so and so topic. We'll complete, we'll go for the next topic. But what is about completed topic? Is it clear? So what are you doing for the completed topics? Those things which are completed, right? You must need to focus. You must need to focus. But what we do, the completed topics will forget. We'll focus on what is not studied. What is not studied only our target. What is studied we never look back. So this is going to be a problem for many students. Okay, this should be taken care from the beginning. Those things which you have completed, put in the revision and practice in once in a while, right? Every week, touch at least once. Okay. Yeah, last week more focus on, practice should be there. List out all the things, easy things anyhow you remember easily, and those things which you are facing difficulty, right, try to spend a little bit more time, and those things which are easy, try to revise quickly. So revision on easy things, so that no need to practice them, but those things which you are not able to remember, which you feel little bit difficult, have a practice on them. So everything no need to practice, everything no need to revise. So when you are practicing, revision is happening, but when you revise, the practice may or may not be needed. So which things need to be revised, which things need to be practiced, that need to be planned well. This 1 week, right? This 1 week revision is needed, but anyhow practice is needed or not, that you decide. Practice is needed, those things which you are not able to apply quickly, those things which you are not able to remember them, right? So there you need to practice. Revision, you have easiness, like if I say finding the number of tokens, why do you need a practice? Right, you already understood the concept, then that's sufficient. Right, those things which are sufficient knowledge you have, then just have a revision quickly. Those things still you are failing, like probability, propositional and predicate logic, undecidability, right, semaphore, and some topics you need to have good practice. There you need to spend much time. Initially you might fail to put enough time. Now you give practice for those topics and revise remaining things. Those things you are not practicing, revise, right? And those things you are facing little bit difficulty or not having confidence, have good practice on them right now. Okay. I saw Sharma, CRM Sharma. Some people even got 30 marks, 20 marks, they got even below 100 rank. So the marks in test series will not decide the marks in actual gate. But getting good rank or good marks will give you boost and confidence. Right? So, but that will not be ultimate decider. I've seen many. Okay? In the gate exam, in the actual gate exam, what you have, what knowledge you have, how do you apply it? If that's going to match, then you will get more marks. Right? Anything else you have? Yeah, utilize every minute, right? You are already working hard. Now you need to have the complete idea what you are doing these days. Okay? So any kind of drawback might impact you. So you don't put any drawbacks like, wasting whole day, or, unnecessarily, giving only test, no revision. So don't keep any drawbacks last moment. Everything is important what you have done so far, and all the things should come into picture in proper manner. So anything you have doubt, just discuss with, faculty, or discuss with those people who are already cracked the gate and they're trying to help you. So ask them, so what should be the strategy last? So many people have, so many strategies. But for you, what is the right strategy? Discuss properly. Right? Anything else? Yeah, Shivam, you can. You can search my name in the Google, right? You get all my details, you can contact with me, right? Yeah. It's very easy to. Good morning, Manshu Pandey. Yeah. So all of them are important. You give some test, but over attempting is very difficult. Don't attempt, whole day's test. Right? That's not the suggested one. What is the average marks one should aim for to get a rank below 1000 based on previous year? You want 1,000? 1,000 is so easy, yeah. Not no need to worry, Sandeep Rai. Getting 1,000 is so easy, I guess. You get around more than 50 marks. Would be you will be under 1,000. Okay. But getting good marks is 50. Target those people who are not having much confidence, right? You are going to touch 50. Anyhow, everybody can touch the 50. The 50 marks in the exam out of 100 is going to be easy level only, right? 70% of the marks out of 100 will be easy to moderate, easy. Only 30% of the marks that will be moderate to difficult. So that out of 70, 50 everybody can secure who have studied with confidence. Yeah. Imanshu, is this right time to discuss that question? Can you bring that into Turing machine session? Nice. Gate Wallah is we are revising and we are making the questions, right? It is true. It's good. Crossing 60 is really good, Shivam. But we are keeping the gate questions relevant to the syllabus. We don't, focus on everything from the subject. We'll focus on everything related to the gate syllabus. Okay, that's good. But if I look at state series from others, right, people ask anything what they want it. They don't look at what kind of questions needed for making the exam pattern. That's very important. You need to be connected. Yeah. Any other? Okay. So can we stop here? Oh yeah. But app you got it right. TOC everybody got from app. So similarly you will get here also. Yeah. Okay. Thank you so much, and I'll be there. And everybody take the rest and ready for the next marathon because you also have the marathon today. That's why I plan to go for part two rather than having even myself I'm tired. Okay. Yeah. See you then. Bye bye.